So everyone connected to your cluster?
Yes, Satish.
Okay. Fine. Let's start. Okay. So today's agenda, what we are going to do is we are going to start with the cron job. Okay. How do I create a cron job? Okay. Then we will create a two-tier application which is going to use the persistent volume. Okay. How I can attach a persistent volume to the container. Okay. And the next step, what we are going to do is we are going to use the secrets on the cluster. So basically, I want to store the username and password. Okay. I want to store the username and password in a secret way, that is in an encrypted way. Okay. So from there, I'm going to use that inside my deployment YAML so that username and passwords are not exposed to the external world. If I want to store it in a endpoint or something like that. Okay. And next thing, what I'm going to do is in the same cluster, I'm going to use a job, okay, which will be loading some data into the database. Okay. So this is the architecture we are going to see in that. Okay. Then we will see about how to run a multi-container pod. Yeah. So in a pod, if I want to run two containers together, okay, how do I run that? We will see that example. Then we will see an example about a config map. Okay, what is a config map and how to use it, where to use it. Then we will also see an example about daemon sets. Okay, we will see all these things today. Okay, so first, let me start with the cron job. How do I create a cron job? So prior to that, let me just connect to my dashboard. So kubectl proxy. So let me run the kubectl proxy. Then let me access the dashboard. Okay. Don't have any deployments or anything running. Okay. So everyone connected to your dashboard also?
Yes, Satish.
Okay. So let us create a cron job. Okay. So basically, I want to run a job which will be running like in a frequency manner. Okay. There, I just wanted to print some information. Okay. So let me just take a minimalistic bash image, which will just print something in that just for our lab. Okay. So you can use any script or anything inside the container. If you want to run that job for a particular point of time, you can just run it. So let me start with node cd global notepad cron.yaml. Yes. Okay. And API version is patch / v1 beta 1. Okay. And kind is cron job, and meta data is, let me provide a name for this. Name is test job. Okay. Spec is, so I need to provide the schedule for the job. Okay. So this literally follows the cron entry. In Unix, we have cron, right? So it follows the same cron syntax for the schedule. Let me provide that. Schedule is, okay. So the first star represents the minute, second star represents the hour, okay. Third star represents the day, fourth star represents the month, and fifth star represents the day of the week. Okay. So for example, if I want this job to run at 10 a.m. every Sunday means I will provide 0. That means 0th minute, 10th hour, and I want it to run on every Sunday means, so it will be the week starts with the Sunday. So 0 means Sunday. So Monday means 1. So this will run this job on every Sunday at 10 a.m. Okay. So this is how we can provide. Or if I want to run on every fifth day of a month, I can use this. Okay. So this is how you can provide the schedule. So here for our example, I want this job to run every 2 minutes. Okay. So I can provide like this */2. This is going to run this job every 2 minutes. So next I'm going to create the job template. And specs for the job template is template, and spec is, this is where I'm going to write the containers. So I'm just going to create a hyphen name test job, and the image should be, okay. There is an image called bash, which will have the bash Linux bash loaded. So I will use the image bash, and let me run the command. Okay. In the bash, I just wanted it to print something. Okay. So if I have a job, I can run it inside the container. Imagine you have a image in which you have configured the job and you want to run the job on the container startup. You can just provide it as a command also. Okay. Here, I'm just going to print something. Echo welcome to and next is I need to provide a restart policy. That means if the container has failed, what I should do. So I want the container to be restarted. Restart policy is on failure. So this is going to restart the container if the particular job got failed. Okay. So let me save this. I will run this and then I will share it with you. So kubectl apply -f cron.yaml. Okay, there is a test job might have been created. Okay, so let me get that kubectl get cron job. So I have a cron job scheduled for this. Okay. So let me just see it in the cron jobs. I can see one job. If I go to that, yeah, I think no jobs has created till now. If I go to the jobs, okay, there is a job got created. So this is what it is ran and it was successful. If I want to see the logs of it, you can see it has printed that. Okay. So basically a cron job has created. It has ran one job. If we go to that and then I will check the logs for that, I can see it has printed. In the command line, let me show you how to see the logs. So this is the job. So let me get the list of jobs. kubectl get jobs. So this is the job which has ran. Okay. I want to identify what is the pod created for the job. If I run the log of the particular pod, I can get it. Okay. So the command is kubectl get pods hyphen sclvctor equal to job hyphen name equal to. So this is the job name which got automatically ran. This is going to get me the pod name created for the particular job. Then if I use the kubectl logs, I can get the log printed for the particular job. So let me give this on your Slack. Please complete it and let me know. Okay. So this is what we're going to do. And next thing, what I'm going to do is, I don't want this to be running all the time. Okay. So let me delete that. So kubectl delete -f cron.yaml. So with this, I'm just deleting the complete job because I don't want it to be running. Please let me know once you're completed. Move on to the next topic.
Yes, done, sir.
Everyone completed?
Yeah.
Okay. So next, we are going to start the two-tier application. So let me just show you the architecture, what we are going to have. So I want a deployment which is going to have 3 PHP application, which is going to expose to the external world via load balancer. Okay. And then I'm going to have one more deployment called MySQL, which is going to expose to this PHP application as an internal service. And in that, I want a volume to be attached. If the container got restarted, I don't have the data will be in the persistent area. Okay. And next is when the DB is up, I want to run a job which will load data into the database. Okay. And the database username and password are kind of stored in a encrypted format. Okay. So that I can use the secrets in the both the jobs, one on the PHP application and also in the data load job. I will use that secrets in the use the secrets. Okay, so this is the architecture we are trying to bring up. So let's start creating that. Okay, so we are going to create them in a particular order. So basically, I want to create the secret first. Okay, then I will create the MySQL deployment with the persistent volume. Then I will create a job which will load the data into the database, and then I will create a deployment with PHP application and then expose it as an external service. So this is the order I'm going to do it. So any questions on this?
Can you repeat once again, Satish?
So basically, I'm just going to bring up a complete application in a YAML. Okay. In this, I'm going to have a PHP based application, which is going to expose to the external world. Okay. Via load balancer. Then I'm going to have a database, which is exposed as an internal internal service. And then for the load balancer, I will have a volume attached to it. Okay. So that it can persist the data which are being mounted to the MySQL. Okay. Then we are going to have a job which is going to load a data into the database. Okay. Then I'm going to have a secret. Basically, when the data load job connects to the database, it needs to use the database username and password, right? There I'm not using the direct username and password. I'm going to use them as a encrypted secret. Okay. In the same way, in the application, it is also going to use a secret. Clear?
Yeah, Satish.
Okay. So let's start creating these things. So the first thing I'm going to create is called the secrets.yaml. Okay. So notepad secrets.yaml. So API version is v1 and kind is secret. Okay. And data. So let me name this. Name as MySQL hyphen credentials and labels. So let me give it as like SP Global. SP Global training. And let me use a LAMP stack. This is a LAMP stack, right? Linux, Apache, MySQL, PHP. So let me use LAMP. Type is opaque. So opaque is a type of secret where the data will be base 64 encoded. Okay. So that's what I'm saying. Type is opaque and data. Okay. In that, I'm going to have three kinds of data. Okay. For the MySQL, I need to have the uh, root password created. Whenever the database is created, I need to create a root password, and then I need to create a user and a password and a database. In that, I am going to store the root password and then the username and the password as a encrypted value. So, okay, so let's just start with this root password, okay, and then user and then password. I'm going to have three encrypted values. So I already have them as a base 64 decoded values. So let me just paste it here. I'll just provide that. So these are Linux base 64 encoded value for those things. Okay. Okay. So my secrets.yaml is ready. So basically I'm going to create a secret with the name, MySQL credentials with the LAMP, with the labels called SP Global Training is LAMP. Okay. And type is opaque. And then I'm going to store three datas, root password, username, and the password for the database. So let me save this. Next, I'm going to create a database.yaml. So notepad db.yaml. Here in the database, the first thing I need to do is I need to create a PVC. Okay. So persistent volume claim. So let me create a persistent volume claim. So API version is v1 and kind is VERSISTE volume persistent volume claim and metadata call it as name is database labels use the same label. Everything is a small one. I just want to validate that. Steady. SP global training. Next is just an annotation saying what is the storage class to be used. Okay, I told you, right? Imagine like in the dashboard, we have a default storage class created. So if I go to this storage classes, if you see that there is a storage class, okay, and so this is the default storage class got created is default storage class. So whenever I create a storage class, the default it will come to this location, okay, and it is Kubernetes.io AWS EBS. Okay, so I'm just going to give an annotation saying that this is a using a default storage class. So annotations annotations volume dot alpha dot kuba.io slash default. Okay, and next I'm going to provide the specifications for this particular storage persistent volume claim. So next is called access mode. Okay, that means on which mode it should be mounted onto the container. So I want it to be like read write once. That means it can be attached to only one container at a time. So it's like a block storage I'm attaching to a container. So modes read read write once, resources STS requests, storage is 1. So it's like 1 GB byte. So this is the notation which has been used in Kubernetes. It's all GB, okay, not GB. So basically, I'm creating a persistent volume claim, which is going to create a 1 GB of block storage, and this I will be attaching to the MySQL container. So first I have created the PVC. So next, let me create a MySQL deployment, which will be using this secret and also my persistent volume claim. So let's see that. Let me create a deployment API version is ext extensions slash a1 1 and is deployment and data is name is MySQL labels is the same label SP global training. Next, specifications class is 1, revision history limit. So basically I want to provide, okay, I want to store 5 deployment history. So I'm just saying revision history limit is 5 and selector TCH LABLS match labels. Let me use a different label here. App is equal to MySQL. Let me use the same label in the template. So selectors is ready in my template. Meta data labels. App is MySQL and specs for this is spec is containers let me use an image SQL colon 5.7. I'm not going to use the latest version, so I'm just going to use only 5.7 and name of the pod should be container should be MySQL. And next is, let me show you how do I provide the CPU limitation. So for example, imagine I want a limited set of CPU to be allocated for this particular container. How do I do that? Okay, so reso.cs resources requests request. So basically, this is where you are going to specify what should be the resources used for this particular container. So I'm going to say it can use 1 CPU and memory is 2 GB byte. Okay, so this container will be logged to use maximum of 1 CPU and then maximum of 2 GB. Okay, if the container is using memory usage is going beyond that, so this memory will not be allocated for that. So you will get a memory error or a CPU error and the container will go down. Okay, so it's always a best practice to provide your containers with the desired CPU and memory limit so that it will be easy for you to manage the hardware requirement for your Kubernetes cluster. Okay, clear guys on this? How to restrict the CPU and memory allocation? Okay. So the next thing what I'm going to do is I need to pass the environment variable. Okay. Whenever you need to bring up a MySQL database, okay, you need to pass default environment variables, that is your root password. So what should be the username and password for a user to create on the database, and what should be the table you want to create. Okay. So these are the default environment variables. So let me pass them. So in the environment variable hyphen name, so the MySQL root password is with the standard naming convention, all caps, MySQL underscore root underscore PASSWORD. Okay. So here you remember, like, we have stored this value from a secret. So let me try to pull the value from the secret. So value from SEC RET secret KEY REF secret key reference. Okay, so the name of the secret which I created is called MySQL credentials. The name is MySQL hyphen CREDENTIALS, and the value in the secret, I have a key called root password. So in the secret, this is what I have provided. So secret name is MySQL credentials and the key is root password. I'm just going to use that. So key is root password. Okay. So like that, I'm going to provide one more other environment variables like the MySQL user. I need to provide that hyphen name is MySQL underscore user value from CCRT KEY secret key reference name is, so MySQL credentials is going to be the same thing, and the key is so I have it as user MySQL underscore password. Secret key reference MySQL MySQL credentials. Key is password. Next is I'm going to create a database. So here I can pass the value directly because for a MySQL database, 4 values are mandatory. One is your root password, then a database name, and a user and password. So MySQL underscore database. I can just directly put the value here. So I'm just going to use the online movie database, okay, which is the example for a PHP application. So put the name of it. So next is, okay, when the container is up, okay, I told about I need to provide the Kubernetes and say when I can consider a container is healthy, right? So for example, if it is a database container, I want to say, right, if the container is listening on port number 3306, that means my container is healthy. So how I can provide a health check information on a deployment is called liveness probe. LIVENESS liveness probe. So this is where I'm going to say you need to open a TCP connection to the container on a particular port number. If the container is responding to the TCP connection, then you can consider this container as a healthy container. Okay, so that is a use of a liveness probe. In the same way, there is one more concept is there called readiness probe. Imagine your container will take somewhere around 2 to 3 minutes to bring up the complete application. Then you need to say to the Kubernetes that when I can consider this application is ready to perform so that I can attach it to the load balancer. So that is where there is one more concept comes in called readiness probe. There you can say if the application or if the container is responding to a particular URL, let's say /index.html, it is returning some value that is 200, okay, then you can consider this container as healthy and you can add it to that. So that concept is called readiness probe. So liveness probe is going to tell about the health check of the container. Readiness probe is going to tell about the readiness of the container. So in this example, we are going to provide a liveness probe only. Okay, clear guys? So I'm going to open a TCP socket on port number 3306. Okay, so all my things are ready. Okay, next in the deployment I need to provide the port number, right, on which port number the container will be listening. So PORTS ports. Next is CONTAINER PORT container port 3306, and next is volume. Okay, so this is where we are going to talk about I have created a persistent volume client that has to be mounted onto the container on a particular directory, right? So this is where I'm just going to create the volume mounts information. So normally MySQL will be storing the data inside var lib MySQL, and inside that you will have a folder called data. Inside that the data will be stored. So basically what I wanted is I want to create a folder called data inside the var lib MySQL, and I want this volume to be mounted there. So let's provide that. So volume mounts. So I need to provide the mount path. Mount path is var lib MySQL, and next is inside that path, I want it to be mounted subpath is data, and name of the mount point should be data. So I'm just providing a name for the mount point, nothing else here. So I'm creating a mount point inside varlib MySQL. I want to create a folder called data, and on top of that, I want the volume to be mounted. Okay. So these are all the informations for my container till now, whatever I have provided. So in the containers, for the containers, I have provided what should be the image name and what should be the CPU and memory allocation for this, what are the environment variables. Okay, then I have provided the liveliness probe. Okay, and I have provided what is the port number and what should be the volume mount I should be using. Okay, so this is the volume mount I will be using. So next is I need to attach the volume. So volumes used for this containers is, so I already created a PVC. So it should be, so volume should be in line with my containers area. Let me just validate that. Yeah, it is in line with the containers. So in the volumes, so the name of the volume is database, and next is I'm going to provide what should be the persistent volume climb should be used. PERSISTENT persistent volume climb, and the climb name is database. So this is where I'm going to refer the initial persistent volume climb which I created. Okay, so I'm just attaching this volume to the container. Clear guys on this topics till now?
So Satish, volume mounts and volumes. Mount is we are giving the path.
Yeah, volume mount is the area which is basically input to my container saying on which directory this volume should be mounted. So in our Docker example, you remember we have created var Jenkins home, right? So that is where I want the volume to be mounted. The same thing here.
Okay.
So this is the directory inside the container where the volume is mounted.
Yep.
Okay.
Thank you.
Okay. So my deployment is done now. Okay. So the next concept we are going to talk about is called, we are going to expose this as an internal service. Okay. Because database, we never wanted it to be exposed as external service, right? So let me just start creating this as an internal service. So API version v1 kind as service, and metadata is MySQL, labels. Let me use the same label. SP global training lamp stack. Okay. Next spec is, so type, I'm going to define it as cluster IP. Okay. Till now, we have seen an example of load balancer, which will talk to my Amazon load balancer and create a value for me. Here, I'm going to use cluster IP. Okay. So this is going to expose this as an internal service. So next, I need to provide the ports, PORTS. So I want this cluster IP to be listening on port number 3306, and protocol should be TCP, and selector deployment label is app colon MySQL. So this is the label I have used for this particular deployment. So I'm just using that. Okay. So my database is ready. Here I have created a persistent volume client, created a container with environment variables, limitations, volumes, and all those stuffs. And at the end, I'm just exposing this particular deployment as a internal service. That's where I provided cluster IP. Okay. So let me save this. So in the architecture, my secrets is ready. My database is ready. So the next step I'm going to do is I'm going to create a job which will load the data into this particular database. So let's do that. Add data loader YAML. API version is patch/v1 and is going to be job. Till now we haven't created a job. We have only created the cron job, which actually triggered a job. So this time we are just going to create a job. The kind is job and metadata just like name. Okay. So let me create the job with a timeout. So that means when this particular job is not completing within a stipulated amount of time, right? I want this job to be considered as a failure. Okay. So that if the job is not completed, let's say within 100 seconds or 200 seconds, I want this to be considered as a failure, and then I want the job to be restarted. So we will create the job with the timeout. So I call it as MySQL hyphen data hyphen loader with hyphen timeout. Okay. Next is labels. Use the same label. SP global training lamp stack. Okay. And next is spec for the particular job. Okay. So next is I told about the timeout, right? First, let me provide the timeout. So ACTIVE active deadline CCONDS deadline seconds. Let me give it as 100. So the job should complete within 100 seconds. That is 1.5 minutes. It should complete. And next is let me provide the template. Data. As MySQL let me provide the spec for the specs for the particular container. So containers containers hyphen name SQL hyphen data hyphen loader. So I'm going to use a public image. Okay. So basically there is a image called Heptio. Okay. Inside that they have an example PHP DB connect. So this is a sample application taken from Heptio. So let me use this Heptio example PHP DB connect. So this is the image I'm going to use. And next is env. I need to pass the environment variables for that. So basically, I'm going to pass three environment variables. One is the database username, and another one is the database password. And next is there is a script inside that particular. My database. Three things I'm going to pass. One is my database URL. Next is my database username, and third one is database password. Okay, so the username and password, I'm going to get it from my secrets value. So environment hyphen name mysql underscore user value from secret key reference MySQL hyphen MySQL credentials is user name is MySQL underscore PKSSWORD password value from name as MySQL hyphen credentials and key is password next is I'm going to provide MySQL underscore. Okay, so here I'm going to pass the DNS entry for this particular service. Okay, so the value is okay. So let me write this and I will just show you. So MySQL dot default dot svc dot cluster dot local. So this is going to refer to the service name MySQL on the default namespace, okay, on the local cluster. So this is how you can provide the internal DNS name. So this represents the service name MySQL on my local cluster in the default namespace. Okay. And next, for the container, I need to provide the command. So basically there is a shell script on this container. I want this shell script to be triggered. So command is slash and next I can provide a restart policy. So basically I want to say when the container is on failure, I want this to be restarted. Restart policy is failure. Okay. So I'm creating a job with a timeout of 100 seconds and I want to use this particular image and I'm passing 3 variables, my username and password and the database URL. So I'm just going to pass the internal service URL. Okay. And I'm just telling what should be the command executed for this particular job. So let me save this. Okay. Clear guys till now? So till now we have created 3 things. One is the secret where I have the username and passwords are stored in the base in a 64 encoded format. Next, I have created a database in that I have created a persisted volume climb and a deployment and I have an internal expose this as an internal service. Then I'm creating a job which will be loading the data into the database. Okay. So next I'm going to talk about is the web layer. Okay. So let's talk about PHP application. So let me write this my DB. This is my secret. Yes. This is my data loader. So next, we're going to talk about my php.yaml. And API extensions slash v1 kind deployment and data name is php-db connect labels is label not this one. Next, I'm just going to provide the specs for this. So spec replicas I want 3 replicas of it as is shown in the architecture, and then vision history limit is 5. Next is selectors. Selectors. Match labels. We provide a new label called app name is php-db connect. Next is your specs for the containers. Sorry, for the template. Selectors, template, metadata, labels, php-db connect. So this is the label. php-db connect. Okay. Next. Spec. Containers. Image. Yes. I'm just going to use the same image which I used for the job. So it's an individual image, like it can be either used as a PHP container, at the same time it can be used to run jobs. To xample php-db connect. Image. Next is I'm going to talk about image pull policy. Okay, so when I want this image to be pulled every time. So let me show you example. Image pull policy is always. So I want the image to be pulled every time. I don't want to reuse the existing image. Okay. Next is name is php-db connect. DB connect. Next, I'm going to restrict the resources. Okay, so URCS resources requests CPU is 100M, memory is 1 GB. Okay, so last time we have used a complete CPU. Okay, one CPU is equal to 1024 units. Okay, so here I'm literally using 0.1 CPU here. Okay, so that's why I have given 100M, because this is a very simple web server, so it should not use more than that. Okay, so next I'm going to pass my environment variables. So here also I'll be passing 3 environment variables: my MySQL host, username, and password. So let me just do it. Name MySQL underscore user from secret key reference MySQL hyphen CRE is user. Next environment variable I'm going to pass is the name is MySQL underscore password. So I'm going to use value from reference is MySQL hyphen credentials and the key is password. So two variables have passed. The next variable I'm going to pass, it is called name is MySQL underscore host and value is SQL dot default dot svc dot cluster dot local. So MySQL default svc cluster local. So this is the domain name I'm providing. It's the host name. So next is I'm going to provide the liveness probe. Liveness probe is TCP SOCKUT TCP socket and port number is 80 and next I'm going to provide the ports on which port the container will be listening. PORTS container PORT container port is 80. Okay, and next is API version v1. So basically I'm just going to expose this as external service. So my deployment is ready with this image and I want to pull the image always, and I'm restricting the CPU and memory, passing three environment variables that's called MySQL user, password, and then host. And then I have provided the liveliness probe and I provided on which port the container will be listening. Okay. So next I'm going to expose the service. Kindness service and metadata name is web labels the global training lamp stack is the label I want to use for this. Okay, next spec yes port is 80 protocol I want it as TCP and selector is app is PHP DB connect. And type is load balancer. So I'm exposing this as a external service now. Okay. So let me save this and start applying one by one. Okay. So let's run cube. The first thing I'm going to apply is the secrets.yaml kubectl apply -f secret.yaml. Let me check what is the error I have made. API version is v1, kind as SCCRET. Thing I may not have this. Should not use the label without a space. Okay. Yeah, credential is created. So basically, the error I had is in the base 64 encoded, I missed something. Okay, and the label should not have spaces. Okay, okay. So this is secret is applied. Next, let me apply the database. So here also I need to remove all the spaces in the label. See. So let me show the secrets first. So if I go to the secrets, okay, you can see that there is a MySQL credentials has been created and it is having the password, root password and the user. Okay, as this is base 64 encoded, in the source code it is encrypted, but if you're logged into the dashboard, you will be able to see the value. So these are all the values for the encrypted things. Okay, so this is how you can provide it. Okay, so the next thing what I'm going to do is I'm going to apply my DB. So let me apply this database. So kubectl-apply db.yaml. The line number 33 I have error. What is that issue? Template. MySQL spec ls MySQL. Any issues here? Let us see whether it is 32 is causing this issue. Containers.
I think it is MySQL colon, right? It should be dash. Because I think it's treating as a complete workspace here.
No. See, colon is the version delimiter for Docker images, so it understands that.
Should it be like, it's just 5.7? Should it be 5.7 point something?
No,
The tag is correct, right?
it is the image name.
Okay.
It can be something I have made a mistakes in the down also. It can be referring to this one because this is the starting line of everything, right? So it could be that way also. Just a moment. Let me just. So I found the issue. It is I'm missing a colon in the value from. So basically, inside this block, it had a data issue. So it showed me that. So let me save this and apply this. Okay. So there is a persistent volume claim created. There is a deployment created, and there is a service created. So let me go back to this and see. So there is a persistent volume created, and there is an internal service got MySQL got created, and there is a deployment dot MySQL is created. Let me give it some time because it has to attach the persistent volume. Yeah, now it is completely up. If I go to my AWS account now, On my region, so this is my region. Yeah. In that, if I go to volumes, I can see there is a 1 GB dynamic PVC got created. Okay. And it is attached to the particular machine. You can see that it is attached to the Kubernetes node. So Kubernetes does everything for you. So basically it comes to the AWS and creates the volume for you. Okay. And it is attaching to the particular instance. From there, it is attached to the running container. Okay. Okay. So the next thing I'm going to create is I'm going to create a job. So let me run the job. Name this data loader. Yeah. Issue I'm having on the data loader. Field restart policy. Okay. I think the restart policy should be in line with your container. Now put it under the spec. That is the problem. Yeah. So I missed that. Let me save it and apply it. Command should be command should be in line with the name and the image. Yeah. File, save. Apply this. My regular mistake. I should not have a space in the label. Save this. Okay. So there is a job got created. So now let me check the job. Okay. There is one thing coming up. If I want to see the pod. Okay. If I want to see the logs. So it's in the container creating state. Let's see. It is in the running running state. Okay, super. So it has downloaded a file and executed that. This error you can just ignore. That is okay. Fine. Great. My job is also completed. Okay. So the next thing what I'm going to do is I'm going to apply my php.yaml. Here also let me make the changes. I don't want it to be with a space. This container port. Okay, I think container port P should be capital. Okay, save. Image pull policy unknown field selectors. So I think I missed some.
I should be small, like as per the convention. I always see it's camel casing.
Which one you're talking about?
The image policy I should be small because, like as per convention, I always see it's camel case.
Yeah. Yes, you're right. Image pull policy. Okay, let me apply this now. Selectors. It's called selector, not yes, selectors. Sorry, it's my bad. It should be selector. Yeah. So there is a deployment got created. Okay, so 3 pods are coming up. Okay. So in the meantime, let me just share this file to you. You can just apply this. So I'm just attaching these files in the Slack chat. Okay, please use that. Okay, and you just apply it. Okay, in the meantime, we'll take a break. Okay, come back, and then we'll talk about seeing the application and service. You need to apply them in the proper order. First secret, next database, then data loader, then PHP. So after we can go for a break, and then we'll come back. Okay, guys, I'm back. So everyone applied?
Yes, Adisha.
Yeah. Okay. So there is a deployment for this PHP has been created. Okay. And at the same time, there might be a service called external service metaphor. Log into this. Just a moment. So there is a external service might have created. If I just search this, this is going to give me the PHP default page. Okay. So my application is hosted on a specific URL. So the file name is /mysql connect.php. You see that it is just printing the list of tables created. Okay. So at the end of your load balancer URL, if you try this with the /mysql-connect.php, you will be able to see the content. So imagine like we have brought up an empty database. In that we have written a job which will create these tables, and this is just printing the list of the tables. So this is an example we have created to bring up a two-tier architecture. In this, we have talked about a couple of concepts: how to store the username and password in an encrypted format. Okay. And adding to that, we have seen about how to use persistent volume, how to attach to a container. Okay. And we have talked about how to expose the internal service, that is cluster IP. Okay. And also we have talked about how to call the internal service internally to a container. We have used the DNS name, and also we have talked about liveliness probe, and then limiting a resource usage per container, like what should be the maximum CPU it can use, what is the maximum memory it can use, and all those information. Okay. This example we have covered multiple use cases like secrets, jobs. Okay. And also we have talked about jobs. Okay. So this is the typical example. Clear, guys? Everyone got this page?
Satish, can I share my screen?
Yeah, sure. Can you just go to the jobs? If the jobs is completed successfully. Just refresh this page. It's not going to the jobs page. Open this job. Click on this job. There is nothing to display here. Okay, do one thing. kubectl delete -f job.yaml, and then apply the job again. There is a failed job. It is failed. Let's see what is the issue. You see this in the status. You have 0 active, 0 succeeded, 1 failed. So the job got failed. So that is the reason you are not able to see the data in the status. Yeah. So let's just delete the job and then apply it again. kubectl delete -f data loader.yaml. Okay, now use kubectl apply -f data loader.yaml. now it is succeeded. Refresh this again. Yeah, now it is getting loaded.
Yeah, thanks.
Okay. So data loader.yaml and then MySQL db.yaml. And what else I had? Secrets.yaml. I can put view only one. So let me just delete php.yaml, then data loader.yaml, .yaml, then secrets.yaml. Okay. So delete all the 4 which we created. Okay. So I should not see any load balancers or anything. I don't want to be additionally charged for this. So in the services, I have only the Kubernetes API service, and then this nothing will be there in the jobs and deployments. So the next example, what we are going to see is, so we have seen an example of how to pass an environment variable in the previous thing, right? Imagine I have a huge file. Okay, that file I want to attach it to the running container so that I can use that. Okay, so let me see how do I use the config map. Okay, so let me see that example. So I told about config map is when you want to pass a multiple environment variables as in a single shot. If you want to pass it container, you can use the config map. So let's see how do I do that. Okay, so let's see an example on creating the config map. Okay, so let's just first create a config map. From there, let me see how can I use the config map. Okay. So vi config map dot yaml. Sorry, bad. Config map dot yaml. Okay. So API version v1 kind is fig config map and metadata. Okay. Name is example config map. Let me call it as example config map. Okay, then I can directly start providing the data. Okay. So I can provide n number of data in it. Okay, so let's say, let me call it as database is MySQL and database underscore URL is MySQL /localhost 3306. Okay. I can provide n number of things. Okay, or otherwise I can provide something like keys also. So that means imagine you have a JSON file or some keys where you can just say like name equal to Kubernetes equal to training client equal to SP. So like this, you can also provide a key value pair, and you can even provide that input in the JSON format also. Okay, so either you can assign a variable to a value directly, or you can use a key also. Okay, so okay, so let's do this. Let's save this, and let me apply this. kubectl apply -f config map.yaml. Okay, so there is a example config map might have been created. So if we go to my config maps, so there is example config map created. So you can see that there are two variables and I have a keys also. Okay, I can just use that particular value, like key value pair thing also it's there. Okay, so let me use this in a, let me create a pod. In that pod, let me just try to use this. So first let me copy paste this for you guys. Now let me show you how do I use this on a pod. Add, let me call it as config map pod. Config map pod. So here, instead of creating a deployment and all those things, I'm just going to create a pod directly. In that pod, let me execute something. Okay, config map pod. So API PRSION. API version is 1. Kindness pod and metadata is pod. The pod is config map pod. Next, let me provide the specs for this. Yes. Config map pod, and let me use images. Nginx, use the Nginx image, and next is env environment from config map reference, and name is, what is the name I have given for the config map? Example config map. I'll just give the name of the config map which I given. So this is one way of doing it, creating the config map from there. Okay, and then from the config map, I'm just using that. So let me save this and let me apply this. So kubectl apply -f config map pod.yaml. Sorry, API version v1. Save this. Specs containers. Indentation problem. So I can see a pod got created, config map pod. Okay. So in that I can run the env command and get these values. Env. You see that? Keys, name, database, all those things are there. Okay, let me just go, show it in the command prompt. So kubectl get pods. Okay, there is a config map pod running. So kubectl exec -it config map pod, and I can just run the shell command on that. Okay, if I just run the env command, so I can see that the database which I provided and the database URL which I provided, and then I can see the keys, name, I can just see all the values here. So this is how I can create a separate config map, okay, and I can use it. Okay, this is one example. So let me just start sharing these informations to you guys. The config map pod YAML. In that, type the env command to see the environment variable which has been passed. Done, guys? Done, guys? Shall we move on to the next topic?
Yes, Satish, yes.
Okay. So till now we have talked about for creating the config map, I need to write something inside of YAML and then apply it. Imagine I have a huge configuration file. I want the complete configuration file to be converted into a config map. And whenever the container is coming up, I want that particular configuration file has to be mounted onto a particular area. Okay. So let's see, how do I do that? Okay. So first, let's say I have a configuration file. Okay. So we will take a Redis as an example. Okay. So Redis basically have this. Okay. So I want to create a file without any extension, because the Redis configuration file is without extension. The file name is called redis-config. Okay. So let me create notepad redis-config. It's going to create with the .txt extension. I will remove that later. Okay. In that, I'm going to provide two parameters. Okay. You can just take it as an example of Apache configuration file or something like that. Here, I'm just going to have a very simple thing. So max MORY is 2 MB. So this is the memory used for Redis. And then next is max memory -policy policy is all KEYS -LRU. Okay. So this is a algorithm used for the max memory. Okay. I'm just providing these two as a configuration parameter for the Redis config. So let me save this as a file and let me remove the .txt extension, because in the Redis, it is going to look for the file without any extension. So let me remove the .txt extension of this file. Okay. So the next command I'm going to do is I'm going to create the config map from this file. Okay. So the command I'm going to use it is kubectl create config map from file equal to redis-config. Oh, okay. I need to give a name for the config map. Let me call it as create config map Redis. So I'm just going to create a new config map called Redis. It's from the file, this thing. Okay. So let me give this command to you guys. So first, let me give the file content. Should be the content of the file, and store it without dot extension with the name redis-config, and then kubectl create config redis-config. Sorry, config map called Redis. Okay, so if I go to my dashboard, if I go to my config maps, I can see one more config map called Redis is created, and this is having this value. Okay, now let me create a pod which is going to add this complete file to a location. So till now we have seen about in a single file, you are going to have multiple values, and then you are going to use that as an environment variable. Imagine I want the config map to be mounted as a file inside the container. Let's see how do I do that. So notepad config map redis.yaml. Just do that. Just a moment, guys. Yes, let's start writing. API version is v1 and kind is pod, okay, and meta data is call it as a Redis pod, Redis, and provide the specs for this. Containers, name of the container, let me call it as Redis, and let me use image yes colon 5.0.4. I'm using a specific version, okay, and I want to bring up this server Redis container with a particular command. So command command is hyphen Redis hyphen server, and I need to provide the config location slash yes hyphen mastr slash Redis dot conf. Okay. And I'm going to pass the environment variable for this. So adding to the config map, I'm just passing the environment variable also. So basically in the Redis container or the Redis image, if I paste master is equal to true, name is master, value is, so this is going to bring up this particular container as a master container for the Redis. Okay. Next, I'm going to give the port number for this PORTS ports. PORT container port is 6379. So this is a default port Redis will be listening. So can reduce. Okay, it's not good. Next is I'm just going to attach two volumes to this. One is to store the data volume, okay, and another one is to store the configuration. So let me use volume mounts. First one is mount path. So red redis hyphen master hyphen data. The name of this is called it as data. And next mount point, I'm attaching two mount points. mount path this slash redis hyphen master name is config. So I'm mounting two directories or two volumes to it. One will be my data volume and other will be my configuration file, which I'm going to use the config map. Okay. So next is in line with the containers. Let me produce the volumes. So for the data, let me mount a empty directory. dir. So this will basically mount a empty directory to the path. And next is for the config, I am going to download the map, the config map. So fig config map, and name of the config map is going to be, I think I have stored it as redis, right? Name of the config map which I provided for this is redis. And then in the items, I'm going to use the key I have created the file with the redis-config, right? You remember, without any extension, I'm going to use that redis-config. That's what I see it here. Item is redis-config. Okay. And I want it to be created for the path redis.config. So this is the file I'm going to use, which is going to be mounted under the Redis master. So let me give the relationship. The mount path is Redis master and the name is config. This config, I'm going to map this config map with the key redis-config as a file name redis.config. Okay. So this is the configuration file I'm providing for the Redis to start. So let me just apply this. So kubectl apply -f config map redis.yaml. So there is a pod called redis created. So kubectl get pods. I can see a redis pod. It's still in the container creating stage. It came to the running state. So let me run the kubectl exec -it. So my pod name is redis. Let me provide redis -cli. So this is the redis CLI. I'm inside the container. So the command to get the memory is config get. So it is having a 2 MB, which I provided in the config map, right? And then next, max memory policy. So if I get the max memory policy, get max memory policy, it's the all keys LRU. Okay, so this is how you can mount a complete file onto the container and you can use it inside the container. So let me give that file to you guys. So next, this is my config map Redis pod. So we have seen two examples of config map where you create a separate config map using a YAML, or otherwise you have a static file. From there you are creating the YAML, and that complete file you are attaching it to the running container. This is the example of the second one is the example of the attaching the complete file. Master cat you can see whatever I have put it in the config map is mounted as the redis.config. This also you can use it to validate. It's done. Everyone clear on the config maps? Shall we move on to the next topic, guys?
Yes, Satish. Yeah.
Okay. So till now we have talked about config map. Okay. So the next concept or topic which I want to show is multi-container pod. Okay. So till now we have talked about a pod containing only one container, right? So let's say, how do I bring up a pod with multiple containers in it? Okay. So let's see one example where I have one container which will be creating a data. Okay. And the other container which will be hosting the data. Okay. So let's see that example. So add multi container dot API version is one and kindness dot metadata is a container and spec is. So basically what I'm going to do is I am going to create a volume that's called, let me call it as a MTDAR. Okay. And that volume, I'm going to attach it to both the containers. In that, one container will be writing data into that volume. The other container will be hosting the data into the volume. So let me see that. So we go yes, volumes. Name, let me call it as a HTML and let me create an empty directory. Empty directory. Okay. Next is I'm going to create the containers. Containers. Let me create the first container. Name is, call it as first, and the image I want to use it called nginx. Next is volume mounts. Yes, volume mounts. The name of the volume mount is HTML and path is so let me mount it to the user share nginx HTML. /HTML. There will be a directory called nginx. Inside that HTML is what I mounted. Next is I am going to bring up another container called second. Image name is Debian and volume mounts is same volume. I'm going to mount it HTML and let me say the mount path is mount path is /HTML HTML. Let me say I want to run a command. Command slash bin slash sh c and pass arguments for the command args. I'm going to run an infinite loop which will be printing the current time into this file. Okay, so while true do date, I want to write the output of date to slash html slash index.html. Then I want it to sleep for 1 second. Sleep 1. Then so basically I'm just running a while loop which will be just printing the current time onto the file index.html inside the directory html. Okay, and this will be writing it to the same mount path, and the same mount path is available on the other container. Okay, so let me save this and apply this. So kubectl -f multi-container.yaml. Mount path. Oh, I think I have given it as a small. It should be capital. Mount path should be capital. Okay, so there is a container which might have a pod got created called multi-container. Pods, multi-container pod. Okay, you see that now it is showing two containers running inside that. Previously in other example you can see only one container. Now you see two containers are running. Okay, so let me just try to run some command exec. Okay, so till now we are using the exec directly on the pod name, right? So if I do a kubectl get pods, I will get only one pod, but there are two containers running on it. If I want to run a particular command on a particular container, let's see, how do I do that? So kubectl exec multi-container, okay, -c first, because I know that one container name is first, slash I can just do hyphen cat. On the first container I will see the value under which area. My first container, it will be under this index.html. Index.html. You see that every second it is printing some value. In the same way, on the second container, I would see the value is under, it will be under slash index dot slash html slash index dot html. You can see. So this is how you can get these details. So this is a typical example of using a multiple containers on a single pod. So in this, one container is writing some data into it, and other container is kind of hosting the data for you. Okay, guys. So this is how you can bring up multi-container, and if you want to run a specific command on a particular container, you can use this option -c and the container name. Try this, guys. Okay, guys, clear on this multi-container prod concept?
Yes, sir.
Okay. Let me know once you complete it. And the next concept we are going to talk about is called daemon sets.
Okay, Satish, before that, like in terms of the Kubernetes objects, like can you share the documentation where we could find like, okay, what are the different kinds? So we did different kind. Like,
Resources available, right?
yeah, correct.
I have shared you the API reference before. Do you have
Okay,
that?
let me check that. It's in Slack. Okay.
Oh, yeah, it's in Slack. On the first day when I talked about the API reference document, okay, I have shared that.
Okay,
I
okay.
have to share it again. So this is going to provide you the detailed information about all the API and all the resources available for that.
Yeah, got it.
Got it?
Thanks.
Yeah, this is where you can just see everything. Okay, guys. So the next concept I'm going to talk about is called daemon sets. Okay. So while explaining the daemon set concept, I have told that like daemon set is something whenever there is a new node get added. Okay. I want a particular pod to be running. Okay. The typical use case will be like your monitoring container. Okay. Or it can be something like imagine like you have a uh, log monitoring situation. Okay, so we have seen that in the Docker lab, all the Docker related informations are stored inside the var lib containers Docker directory, right? Var lib Docker, and then inside the containers directory, you can see all the containers. If you read that file, you can get the logs of it. Okay. Imagine I want to set up a log shipping concept where all the logs created under the var lib Docker containers folder, I want it to be pushed into a centralized sorry centralized elastic search. Okay, so in that case I want this container to be running as a daemon set. Then only I will be able to push the logs. So for example, on the runtime, imagine if I'm adding a new node, okay, and I want this log shipping container should be running. Okay, so there I need to define this as a daemon set. Then only whenever a new node added to this particular cluster, it will be automatically fetching the log files and then push it to the centralized Elasticsearch. Okay. So this is what I'm going to do now. So hope you guys are aware of this ELK stack, right? Everyone aware of this ELK stack in the monitoring world?
Yes, Satish.
Yeah. So, like in the ELK stack, Elasticsearch talks about all the logs are kind of indexed in the Elasticsearch, and Logstash is going to collect the log and push it to the Elasticsearch, and Kibana is going to host the like you can convert the data into a graph and then you can put it there. So that is what the ELK stack. In Kubernetes world, it is called as EFK stack. Okay. Instead of Logstash, it is called as fluentd. Okay. So this is the example I'm going to give it as a daemon set example where fluentd is going to act as your log collector. So whenever a node is added, I want this fluentd container to be running on that particular node, which should start collecting the data and pushing it to the Elasticsearch. Okay, so let's start writing this. So notepad daemon set .yaml. API version is app/v1 and kind is daemon set. Okay, and metadata name is FLUETD and labels app equal to fluentd. Let me just give a name of app is equal to fluentd. Okay. Next, let me provide the spec CLDCTOR selector is labels name is fluentd. We use that as a label. Then template data labels name is fluentd and the spec for this. Spec. Spec. Tolerations key. Okay, so I wanted to run it with a particular role, node hyphen role dot dot io slash master. Let me just explain this. Effect is so basically what I'm doing is, if there is any master node running on this cluster, don't run it there. That's what I'm saying. Don't schedule the this particular daemon set on the master node. Tolerations is like, if it is a master node, okay, don't schedule it. That is the tolerations I'm providing. Then is your spec. Oh, sorry, not spec, containers. Containers. Let me provide name and the image. Okay, there is a public image under Montech user. We use that particular image. Okay, so this is the image for the front D. Let me use that. And next is, I'm going to talk about volume mounts. So I need to mount two different volumes. Okay. Hyphen name. So basically, I'm just going to get the var log. So var log is the default location on any Linux based system that will be storing all the logs there. So let me mount that. Mount path is /var/log, and next volume I'm going to mount is hyphen name. Okay, so var web docker containers mount path is /var/lib/docker containers. And next is, I want them to be mounted with the read only, because I'm not, this is just a log monitoring container. So I don't want it to write anything on the location. I want it to be mounted as a read only directory. So read only is true. Okay. Next, let me provide the volumes information. So basically in the volumes, name should be var log path is, so basically I'm just attaching a path from the host machine to this. So path is /var/log, and next is name var lib docker containers path is var lib docker containers. So from the host, it has to mount these two directories onto the frontend container.
Satish, one question.
Yeah.
So basically, if we see at this file, we see like this is kind of a nested spec kind of a structure, right? So could you explain it once more, like why we would need it that way? Because earlier looking at this, I was thinking, okay, spec would always have containers and then you'll have it like that. But now this is a nested spec. So what's the need of it to be a nested spec? If you could explain that, please.
Sorry, I didn't get your question. Nested spec means
So if you see like the spec, so we have the spec, like the above spec, like the above section. So we have this spec, and like this, the below spec is a part of the above one. Like I'm not sure if I'm understanding.
I'll just explain you. Okay, this spec is for the daemon set, right?
Correct.
So first I'm creating a daemon set. So for that, I'm just providing the spec as you should match this label called name frontend template.
Correct.
So this is where I'm just doing the match labels, right? So for the template, I have the specs.
Oh, I see. Okay.
So this spec is for this particular template. This spec is for the daemon set.
Okay. Looking at the the spaces and the intent, I thought it's a child or it's a part of.
No, it's not a child. Okay. So basically, this spec is for this daemon set, and that spec has a template, and this is a spec for this particular template.
Got it. Yeah. Thanks.
Okay. Yeah. So let me just save this. Okay. Let me run this. kubectl -f set.yaml metadata. It is metadata where I did it.
So essentially, Satish, if we do not apply any selector or any filter, it would by default run on all pods, right?
Yeah, if I'm not doing any selector in that, it is going to run on all the pods.
Yeah.
Okay. So there is a daemon set got frontend got created. So if I go to my this thing, if I select my daemon sets, okay, there is a daemon set got frontend is running. So if you see that it is running only one pod because my cluster has two missions. Okay, but while bringing it up, I told that you should not run this daemon set on a particular host. Like if the role of the mission is master, it should not run it. Okay, so just for your example, let me do one thing. Just keep it like I have only one frontend pod is running now. If I go to my pods, I can see only one frontend is running. Let me go to my Amazon. Okay, on my particular region as my Mumbai, let me increase the auto scaling for 2. So that means it will automatically add a node to my cluster. So this is my auto scaling group. Okay, let me edit this. If I make it as 2 and min should be 2. So this will bring my cluster to 2-node cluster. Literally a 3-node cluster, 1 master and 2 nodes. So let me go back to my nodes. So currently there are 2 nodes only there. Let's give it some time. Very soon I can see 3 nodes are added, and then I can see one new pod is getting added to the daemon set once the node is getting added. Let's give it some time because the mission has to come up. So go back to this instances. Okay, I can see the new node, but it is still in initialized stage. What's the current status? Okay, it has become 2 out of 2. Now, in the nodes, I should be able to see 3 very soon. Let's give it some time. Get nodes. While it is coming up, let me just share you this YAMLs and stuffs. Just give it a few more minutes so will it get added. Third mission is getting added. Let's give it some more time. Okay, so it is up. If you go to my pods, you can see automatically one more pod got added and it is added to the new mission which was brought up. Okay, so this is the advantage of daemon set. If you increase and decrease the number of nodes, it's going to automatically create that for you. Okay, if I go back and then let's say, let me modify it back to the original thing. So let me say one should be the desired capacity and one should be the min. If I do that, the instance will be terminated and it automatically does the health check and then it will reduce the pod, one more pod. So daemon sets, now it is 1 out of 1 because I have only one node available, right? So this is how you can use the daemon set. With this, you will be able to control things. Okay. So with this, we have already talked about the namespaces, nodes we have talked about, persistent volumes. If I had the 1 GB, I can just see that here. Storage classes we have seen, it's the GB2. Cron job we have seen an example. Daemon set we have seen an example. Deployments we have done. Jobs we have seen an example. And pods and replica sets we have seen an example. And then services we have seen. Config maps we have seen. Persistent volume we have seen. And then secrets we have seen. Okay. So the next thing what we are going to talk about is called Prometheus. Okay. So we have talked about this fluentd for doing the log monitoring, right? But we may also need to do the infrastructure monitoring, like what is the memory usage of a particular container? How do I do that? So those kind of information we need to do. Okay. So we need to do that. There is a tool available that's for called Prometheus. Okay. So let me just see an example, show you an example of the Prometheus. Okay. How to implement a Prometheus, and it is going to show me a dashboard. And in the dashboard, how I'm going to access this or filter a particular value. Okay. And with that, we'll be concluding for today. Okay. Tomorrow, we are going to talk about Helm chart. Okay. Helm chart is an example of instead of writing the complete YAML file, okay, you have a template. In the template, you just modify some of the couple of the values, and you will be able to host the application using Helm chart. Okay. And next thing we are going to talk about is the Istio. Istio is a service mesh concept which is deployed on top of the Kubernetes. We are going to go in detail about the Istio. In this, we are going to talk about how do I do the canary based deployment, and we are going to see a detail about the Istio architecture. Okay, so that is where we are going to plan for tomorrow. Like with that, we'll conclude this complete curriculum. Okay, so till now, is there any questions or any other topics which you want to discuss before we move into the Prometheus?
Yeah, Satish, one thing. So like in terms of the dashboard access, so when we'll be hosting, there would be different user permissioning we need to apply, right? Different users. So how we would control that, if you could tell us about that.
Okay, so when you see about this, when we created this dashboard, we have created a cluster role admin. You remember? Like it was an existing role. Okay, so that is having complete access to this particular thing.
Correct. Yeah.
What is this?
So in terms of like if we need kind of a custom role, and because like
Yeah.
there will be multiple users interacting with this cluster, right?
Yeah. So you have to create your own role. Okay, and then you create a user and assign the role. Okay. In the Prometheus, we are going to create a role. So what we are going to, I will just walk you through the YAML. We are not going to write it line by line. It's a huge one. Okay. So in that, we are going to say what kind of access this particular Prometheus is going to be needed. Okay. I'll just walk you through that. Okay. So there you can just talk about what are the kind of resources this guy should have access to. Okay. When you create a role, you can just say, what are the kind of resources this guy should have access to and what kind of access he should have it. Like for example, if you talk about a monitoring system, he should be able to list or watch a particular resource or get information about a particular resource. He doesn't want to write anything there. Okay, so that's the kind of role we are going to do, create for the Prometheus. Okay, I will just show you the example. Okay, like that. Imagine if you want a particular user who should be allowed to create only deployments. He should not get anything as a service. Okay, you should not create any service or anything. Then what you will do, I'll just open this Prometheus thing and I will show you. Cluster role.yaml. Yeah, this is what I want to show. You see this? This is the cluster role which I'm going to create it for the Prometheus. Okay. So I'm going to say in the resources, he can have access to nodes, node proxy, services, endpoints, pods. He can do only get, list, and watch. Okay. He should not have any write access or anything like that. Okay. So like that, I can say for the deployment, for the resource deployment, he can have a write access. Okay. For the services, he can have only read access. That is get, list, and watch. In this case, I can create a role that is he can create a deployment, but he cannot create a service. So this is how you can create a role, and then that role you can assign it to a user.
Got it. Yeah, makes sense.
Yeah. So this is what we are going to do it for the Prometheus also. Okay. So what I'm going to do here for the Prometheus is, okay, there are a couple of things. I will just explain them. So these are all the things I'm just going to show you guys. Okay. First is I'm going to create a new namespace called monitoring. Okay. In the monitoring, I'm going to create a cluster role where this user can have access to particular node groups. Like he can have access to node proxy, services, endpoints, like get, list, and then watch. Okay. And then he can just have access to ingress. Okay. And then he can get the metrics. Okay. And then the role name is called Prometheus. that Prometheus role, I'm just assigning it to a basically I'm just creating a user called Prometheus and I'm just assigning it to that. Okay, so this is what I'm doing as a first step. I'm creating a cluster role. I'm just creating a cluster role binding for the user Prometheus. Okay, next thing I'm going to do is, so first I'm creating a cluster role. And next I'm going to create a config map. So this is what the config map is all about. So basically we talked about config map, right? Where I can just create a config file and I can just push it to the container, right? So here I'm just going to create a configuration saying I want this to be every 5 seconds it should just get that things, okay, and it should get the rules from this directory etc prometheus.role rules, okay, where I want this rule to send out a notification, okay, when there is a high memory usage. Okay, like this, using this config map you can write your rules for alerting mechanism when a particular memory usage is greater than 1 or something like that. As this is the example, I'm just saying even if it is more than 1 MB for 1 minute, you just send me a notification so that I can see the notification there. Okay, and like that you can have multiple configurations. I'm just adding that as a config map. Okay, and next thing is I'm going to create a deployment. So basically in the namespace monitoring, I'm going to bring up one deployment. Okay, so this is going to install the Prometheus container on the master. From the master, it is just going to get the value and then show me there. Okay, next I am going to expose this as a external service. Okay, so basically Prometheus will be running on 1990. I want it to be mapped to the port number 80 of the load balancer. So this is what I'm going to do. Okay, so let me just start doing this. So let me share all these files. So this is my service. SP global. So this is the service.yaml deployment. Right, save us. Deployment. Save us. SP global config map.yaml and then cluster role file. Save us. Cluster. Okay. So let me share all these things to you. Cluster role config map deployment PPA. So all the 4 files, keep it in the directory there. First, I'm just going to create a namespace called monitoring, and I want everything to be created under the particular namespace. So kubectl create. So first let me create the namespace. So still now I don't have a namespace called monitoring, right? Kubectl create namespace ing monitoring. Okay, there is a namespace called monitoring created. So next is, first let me create the cluster role. So kubectl apply -f cluster role.yaml. Okay. Next, I need to create the config map kubectl apply -f config map.yaml. Oh, sorry. Config. I think this config properly. Configuration map only. YAML. Okay, there is a config map bot created, and then -f Prometheus deployment. Just validate one thing. If I'm just creating under the same namespace, so I'm in the monitoring namespace. I want to see the config map. Yeah, just created under the config map. Okay, and also let me just validate the deployment file. Prometheus deployment. So here also namespace is mentioned, so I'm good. So let me apply the Prometheus deployment. So I've created the cluster role, config map, and then Prometheus deployment. Okay. Next, I'm going to expose this as a service. So I know that in service, I may not have mentioned the namespace, so I may need to provide the namespace. You see, in the service, I haven't mentioned the namespace. So let me provide the namespace here. So kubectl apply -f pyo.yaml -n. So only for this service, I'm just going to create and mention the namespace. So let me just give them in the order. First, you are going to create a monitoring namespace. Then apply the cluster role. And you are applying the config map. Then the deployment. And then you are applying the service.yaml, that is pyo.yaml is the service YAML. But there, as inside the YAML, I don't have mentioned the namespace. I'm just going to provide that while during the apply. So if I go to the services now, I can see an endpoint. So let me give some time. So by the time the service will be up. So everyone please apply these 4 files. So this is going to create a cluster role and a cluster role binding. Then it is going to create a config map. Then it is going to create a deployment, and that deployment I'm going to expose this as a external service. So everyone applied, guys? So you see this, guys? Everyone got the service? So everyone got this page?
No, Satish.
So it's applied,
Can
right?
I? Yeah, I applied all files. Can I share my screen?
Yeah, sure. Click on that external endpoint. I think it is loading. Yeah, it is coming.
Means I added this namespace here.
You can directly do that also.
Yeah. Thanks, Satish.
So see, what I wanted to show here is, okay, there are predefined metrics available. Okay, let me talk about memory. So if you see about, these are all the predefined memory specs are available. So what is the memory cache on the container? What is the memory usage? What is the memory swap? What is the memory limit? Okay, what is the missions memory, that is node memory? All these things we can do it like that. We can also have it like a CPU. What is the CPU load average for last 10 seconds? What is the CPU shares? Okay, how many mission CPUs are there? So there are lots of predefined informations available. Okay, so let me show you an example for memory. Okay, so I want to use the container memory usage. Okay, if I just click on execute, it is going to list all the containers memory usage. Okay, there I will be able to filter it based on the container name. Okay, so let me talk about a pod. Let me just talk about not this pod. Let me just go back to my default namespace. Okay, there is a pod called Frunanti. Okay, which is approximately equal to, or let me just say, I want to list all the memory usage of the container, okay, belong to the kube system. Okay, I can just use something like this. Sum of, so this is going to show me only on the data point. Of cube system. I think currently there is no data points available. It is still collecting the data. Image. Approximately. Just get something here. Execute is equal to. Okay, so let me just filter only for this particular image name. I can just do to execute. Oh, okay. I have multiple images. Let me remove one. Okay, so this is going to list all the containers which is going to have this pass container. So this will be the pass container, or let me take another example. Other than pass, do I have anything? Of them are pass containers. Huh? I don't image. Control F. Pass container. Okay. I have a Frunendi. Instead of that, do I have any other thing? Just say something like this. Okay, let me take this image is equal to, I have a Prometheus image. So I can use filter image is equal to, instead of the complete thing, you can just put approximately Prometheus star and then close this and then execute. There is no data for it. Okay, I have something. Execute. I can get it for this particular container. I can just see what is the memory usage. So it's kind of keep on going like this. You can use multiple filters and then use them. Okay, so this is with the image name, or if you want to just filter it for a particular node, you can just see that. Okay, so for the Kubernetes IP host name is this. So if I want to give only this particular value, So this is for this particular host name. So this host name is having this much containers. I can just use that. So it is going to give me the list of this like this. So like this, you can just select multiple things and you can use it. And in the alerts area, you can just see, I have intentionally put one high alert thing. I'm just seeing it. So if you can just have multiple graphs and then you can keep it here, and you can see the things and that. I think we can continue that tomorrow. Okay. So we'll see a bit more example of this graphs and stuff. Okay. So with this, we can conclude this for today. So you can put multiple filters and create your graphs. That's the basic thing about Prometheus. Okay. So clear, guys?
Thanks, Satish.
Okay. Thank you.
Thank you, Satish.
Yeah, thank you. Okay, guys, let me start now. Hey, there was a problem with the load balancer cleanup, okay, because it was deleted some of the critical services of the cluster. So we have to recreate the cluster. Can you just log into your AWS console and recreate the cluster with the same configuration? Are you able to hear me?
Yes, Satish.
Yes, Satish.
Sure, we'll create that. So what happened like while cleaning up the load balancer? Like
Cleaning up the load balancer, mistakenly the API load balancer got deleted.
oh, okay.
So that is the reason we had to clean up. Because I was just writing a script which has removed the API load balancer itself.
I'm sure we'll create that. Okay.
Yeah. So same concept. So we'll choose the file. Next, stack name will be cube-my name, and the availability zone, the first one, and admin ingress will allow it to 0.0.0/0, and select your respective key. And next is node capacity is 1 and the disk size is 20. Altogether, we are going to keep the default. Click next. Next. In the last page, I acknowledge and then create stack. Let's wait until this is getting created. So everyone creating the cluster, right?
Yes, Satish.
Nested was completed. For me, the stack is completed. Seeing others, I think Rajshekhar Reddy it is completed. And Ishan and Sai Krishna, it is still in progress. And Sunny, it is still in progress. Let's give it some more time. So I'm just going to follow the same thing. I'm just going to go to the outputs and get the latest kubeconfig file. So once the stack is up, let me connect to the based on host. This is my IP of my jump host, or is based on host. And the username is Ubuntu. There, let me copy paste the PIM file to connect to the master from there. So this is my PIM file. Copy this. Okay. E.pim. Insert. Let me save this. chmod 600 key.pem and ssh -i key.pem Ubuntu at the rate of master IP address, that is 10.0.27.18. That's mine. Okay. Let me get the kubeconfig output. Let me copy this. And on my local machine, on the .cube, let me update the config. Create this config. So it is done. Once the config is copied, I should be able to ctl get nodes. I should be able to get the status. So let me know once everyone has copied the config and you are able to get the output of kubectl get nodes. Almost everyone, the cluster has completed.
Satish, can you show me once again how to set up these? Sorry.
So basically, your cluster is up, right?
Yes, sir.
So basically in this, you're going to get the public IP of your based-on host. Okay. So you just connect to that server on PuTTY. Okay. So that's what I have done here. So I have connected. Then
Can I share my screen?
yeah,
Satish?
sure. You're connected to the it seems you already connected to your this is your based-on host. Okay. So now let me get the PIM file, okay, and create a key.pem. So vi key.pem. Yeah. Inside that, let's copy paste the PIM file on your local. Which one? Open it in Notepad, yeah. Copy the content, paste it. Save this file. Now chmod. No, there is no space. chmod, there is no e at the end. Yeah, space 600 space key.pem. Now SSH -i key.pem. Okay. Now go to your CloudFormation output. There you can get the IP address of the master. Yeah. Click on the outputs on the top. Scroll up. Yeah. Click on the outputs. Yeah. There, get the Ubuntu at the rate of 10.0.0.58. Space is enter. Yes. Okay. Now maximize the screen. Put the screen. Cat space cube config. KUB. Config. Enter. Copy the content from the API version till the end. Okay. Now go to your local machine. Go to your home directory. See users, your username. C drive users. Inside that, this is your username. Yeah, .cube. Yes. Edit the config file. Yeah. Delete everything and then paste the content. I think it is having some extra line. Remove the first line. So in the file, there is an extra line. The cat scheme in there. The first line. Ubuntu at the rate. First line. Yeah, save this. Now go to open a command prompt and then run the kubectl get nodes command prompt. Go to the directory where you have the kubectl exe. I think you have put it on a specific directory, right? Kubectl get nodes. Yeah, you're connected now.
Thanks, Satish.
Okay. So the next thing what I'm going to do is I'm going to create the user and all those stuffs, right? Because yesterday we need to create the user for the dashboard and get the token. So let me just give the commands to you in Slack. So we already have those files. We go into the directory kubectl apply -f user.yaml, and then .yaml. Then let me just give this command ctl get secret. So this will list all the secret in the list. So I will get the first token. So let me just describe the particular secret. So kubectl-n kube system describe secret. The first secret name, the admin user token. And I will get the token. We copy paste it on a notepad. Then let me run the kubectl proxy. Once I started running this, I will be able to access the dashboard via this URL. Token. Let me copy paste the token which I copied right now. Okay. I'm connected to the dashboard. So guys, let me know once everyone connected to the dashboard. Then we will proceed with the Prometheus.
This I have one doubt here. So,
Mm-hmm.
since we have taken that right cube.config, means we are going to the footy and then we are taking all data and then copying in the local machine.
Yes.
Is there any other way we can do the same thing via the AWS CLI, because the cluster is created, right? Just we can connect and take.
See, this is not a AKS cluster. Okay, there is no. So basically, you can literally do it if you have a Windows machine. Sorry, Linux machine. Okay. So basically, I need to on a single command I can get the SSH and I can copy the file. Okay. But as it is a Windows machine, we are doing this approach. Instead of that, if you have it as a Linux machine, I can do a SSH proxy, or if you have a SSH Win SSH installed on your Windows machine, you can do it. Okay, I don't want to install the Win SSH and other stuff. That's why we are manually doing it. Okay, so if you have the Win SSH installed, then you can run this command completely from your machine. It will automatically copy the file to your local.
Okay. So if we have the EKS cluster, then we can do the AWS CLI, right?
Yeah, EKS cluster, you just run the get context. This is going to give you the download the config file on your behalf.
Okay.
Done, guys? Everyone, you're able to access the dashboard?
Yes, Satish.
So next, I'm just going to repeat the same step what we did for Prometheus yesterday. I've explained about the cluster role, config map, and all those stuffs, right? So let's just apply that. CD global. Okay. So the first thing I'm just going to do is I'm just going to create the namespace called monitoring. Then kubectl apply -f cluster role. Okay. Then config -map.yaml, and then deployment is deployment.yaml, and then I'm going to apply the pyo.yaml. As I don't have the namespace mentioned in the YAML file, I'm just going to give the namespace in the apply command. Okay. Now I should have the Prometheus there. So give everything there. So once it is done, if I change the namespace, I should see a service got deployed. I can see the so when the Prometheus got deployed. Done, guys? Everyone, Prometheus is up. Is it up, guys? Are you able to hear me?
Yeah, we are able to hear you, Satish.
Is it up? Shall we proceed, or you want me to wait?
It's up, but it's off for everyone, right, guys?
Yeah, it's not fun.
Okay.
Okay.
So normally in a real-time scenario, okay, Prometheus will not be used as an individual component. It will be normally mapped with Grafana. From the Grafana, you will be creating the graph, because Prometheus is not a very good tool for creating the graphs. Okay. So we will have Prometheus, which will be responsible for collecting the data from all the containers or pods running on this particular uh, a cluster, okay, and Grafana will be used to create some meaningful dashboards like graphs, okay. Here you will not get much options to create different graphs, okay. So let me just start seeing some of the couple of examples, okay. So let me start with memory usage, okay. So imagine I want to list all the memory usage of all the containers. Okay, so this is going to list memory usage of all the containers. If I want to filter it for a particular container, I am going to give the container name or the container filter, okay, in the specific field. Okay, so let me just do something in the image. All of them are pass containers. No, pass containers. Okay, so let's say I have this image. Okay, let me just use that. So I can just put that in the curly bracket, okay, and then click on execute. Okay, I missed the quotes. Execute. So this is going to list only the memory usage of this particular container. If I see the graph, I can see it is kind of increasing. Now at this time it kind of decreased. Okay. For example, if I want it only for a particular period, I can just use something like 5M. That means it is going to give only for the 5 minutes. Let me just say it as a rate of RATE, rate of this, and then close this bracket. So I want to get the rate of this. So this is going to give me the last 5 minutes rate, okay, for the particular container. Okay. So like this, you can also do for the all the pods which are only, let's say I want to monitor only the CPU usage by the Kubernetes pods. Okay. So, okay, let me just give that to you guys. For example, I have given memory usage bytes. So this is going to list all the memory usage bytes. And if I want to filter for a particular image, I can provide the image name. Okay. Let me just put it for the Calico. Pod name Calico. So I would see 3 pods. So I can just put them in the thing. Oh, I will get only one, or I will just put it like one star. Pod name. Execute. I will get it for the particular pod. If I see the graph, I can see the memory usage for this particular pod name. Yes, I can use it. And if I want to create a rate of it, like average of this, so I can just use like wait for the 5 minutes. So I can just give it like rate. Give it for 1 minute. Okay. If I execute that, this is going to give the usage for the 1 minute period for this particular container. This I can use it. Okay. So in the meantime, let me just give you the couple of other queries. So basically, I want to use get the CPU usage for all the pods which are belonging to my cluster. So I can use something like this. So let's say I'm just going to find the CPU usage where the pod name is not equal to pod. That means only Kubernetes related containers I want to get the CPU usage. If I execute that, I can see this is the CPU usage for my Kubernetes related containers. All the pods belonging to the cluster. Let's give it to you. So like this, I can also find, let me say I just wanted to get the Kubernetes cluster CPU usage. I can do that. So I can just, if I want to give by the pod name, Kubernetes cluster, what is the CPU usage? By pod name, I can get that. So you can see these are all the Kubernetes related pods are running, and this is the CPU usage of this particular pods. Okay, so this is, you can also group by the pod name. This is another example. It's going to list all the Kubernetes pods CPU usage. Okay, or if I want to get the CPU usage by the namespace, I can use it by the namespace. Currently, I have 4 namespace available if I'm right. Yeah, monitoring and kube system. Only these 2 systems have that. So for the namespace system base, I want to run this query, I can run it. So like this, based on that, you can have run multiple queries. Okay, based on your need, you can just get that. So these are all these some of the examples. Okay, you can also get by apply some things also. Memory limit for the entire cluster, you can also use that. So we just say, so I can run a query using star and slash. Sorry, this. I don't have any data. Pod container resource. I haven't limited any memories on the container, right? If I have any containers with the memory limit, I would get some update for this. But I don't have any containers by memory limit, so I don't have it. So you can also use this option to get the memory limits assigned for the particular cluster. So I don't have any limits right now, so that's why it's not giving me any data. Okay. So like this, you can run n number of queries. Okay, do that. And next area I want to highlight here is called the alerts. So alerts are something which I already configured in the config map. If you remember, while explaining the config map, I have explained that I have a config map created, and that memory usage is more than 1 MB. I want this alert to be created. Let me just show you the config map which I created. Config-map. Yeah. Bad. Yeah. You see that? So this is a demo alert which I configured. So basically, if the container memory is usage is greater than 1 MB, I want it to be given as an alert. So that's why it is just giving me this information. For a sample alert, I have put that. So high pod memory. So this is sum of container memory usages greater than 1 for 1 minute. I want this alert to be created. So I can define the severity, and from there I can just pass it on to any third-party systems. Okay. This on the alerts. You can create n number of alerts based on your need. Next is the graph. You can just keep on adding graphs and create a dashboard here. But effectively, Prometheus is not a good UI based tool. So basically you will collect this data in Prometheus and use Grafana to create the graphs from here. Okay, if you want, you can also create multiple graphs and then put it here. Okay. Next is you can just talk about what is the information about this particular Prometheus. Okay. So this is the working directory of Prometheus. What is the build version it is using, Go version it is using, all those things you can just see. So you can just talk about all the command line fags which are being used for this particular Prometheus. Then configurations, you can see the configuration file. This is what I have given in the config map. The same thing. And if you want to see the rules, you can just see that I have currently only one rule available. Okay. And if I want to see the targets, what are all the things are getting monitored, you can just see that. So there are service endpoints, nodes, CA advisors, API servers, all these things are currently monitored. I don't have much of the pods running on this cluster, so it's showing only this. And then it can be also used as a service discovery. So you can just see what all the labels are being used for discovering the service coming up in the cluster. So these are all the things you can just do it. You can just read the docs there. You can just see the multiple alerting best practices and all those stuffs. So this is a very high level about Prometheus. So we just wanted to give an introduction to Prometheus and show you some example queries we will execute to get the details. Okay. Clear guys on the Prometheus?
Yes, Satish. Yeah.
So the next area we wanted to discuss is called Helm chats. Okay. So what is a Helm chat? So till now we were writing the complete YAML file, right? For a deployment, if I want a deployment, I need to write the complete YAML file. And if I want to expose it as a service, I want to create the complete service and all those stuff. So if you see that most of the cases, we were like kind of redoing the stuff. If it is a deployment, we know that there is a default standards available. So only things I'm going to change in the deployment is number of replicas, or what should be the image name I should use, or if there is any CPU on memory I want to increase or decrease. Okay. What if I have a tool, I can just give only the varying parameter, and that parameter will be applied to the particular YAML and getting updated automatically. That is where Helm comes into picture. Okay, this is going to help you to write the deployment YAMLs or manage the deployments YAML faster. Okay, so let's see an example. How do I do that? Right? Okay, so Helm is another executable. Okay, so we can just see that install that on the local machine. So this is also available as a downloadable exe onto your machine. So Let me just give you the link where you can download the helm.exe and you just store it on the same location where you have the kubectl. So let me give the link to you guys in the Slack. So this is a zip file. So you just download the zip file and there will be a helm.exe inside that link, and copy paste that onto the directory where you have the kubectl. I already have Helm installed on my machine. Everyone copied the helm.exe on the location.
Yes, Satish, for Mac we have installed like via Brew installer.
Yeah, for a Mac you can install it via Brew. Yeah, you can do that. So before initializing the Helm, let me show you the pods. Okay, kubectl get pods hyphen name namespaces. Okay, so these are all the list of pods which are currently running in my cluster. Okay, let me run the Helm init. Okay. So in the, what is the version of Helm I use? 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. 1.0. version. There's no hyphen. I'm using 3.1.1. Okay. So in 3.1.1, there is no need for initialization. We can just start using the Helm directly. So that is why this is okay. So Helm init is not needed. Okay. So prior to this older version, there is a component called Tiller, which will be running on the Kubernetes cluster, which actually enables the communication between the Helm client and the Kubernetes cluster. But from the version 3.0, they have stopped this concept. So Helm init is not needed. Okay. So let's first start creating a sample template. Okay. So let me create Helm create Helm create. Let me call it as a first template. Okay. So once you run this command, it is going to create a set of directories. I will just walk you through what are all the things it's going to create in the directory. So it is going to create a directory called first thing. Okay. Inside that, it is going to create this folder structure. Okay. So let me just walk you through one by one. Okay. So basically, there will be a folder called templates. Okay. In the templates, you can just see it has created deployment YAML in this. In the deployment YAML, it is going to have the deployment YAML pre-configured. In that, the respective values it is going to get from a particular file. You see that it is going the apps v1 kind is deployment and metadata in the name. It is going to, you can just get the full name and do that. Okay, specs, how many replicas I want, all those things I can get it here. So it is going to provide me the complete YAML. From there, the value is getting populated from a different file. I'll show what is the file. So this is the deployment YAML. So let me just show you the service.yaml. So normally when I want to explore a service, I will be having this deployment and service, right? So inside the templates, I have the deployment YAML. So if I want to create a service.yaml, you can see normally in the service, I will provide that name as service and then provide this information. In all these informations, you will getting the value populated from the file called values.yaml. Okay. So this is the file where you are going to provide all the informations. So for example, if I want to provide the replica, how many replicas I wanted for this deployment, I can just update this values.yaml and then I can do it. So this replica count will be referred in my deployment like dot values replica count. Okay. And like that, if I want to say that, okay, image pool, what should be the repository I should use? If you see that in the image, in the container spec, the image values image repository and then colon chart app version. So in the values, I don't have anything called app version. So it will be empty. If I want a particular version, I will just name it as app version and start providing that. Okay. So like this, I can provide it. And then in the service type, I can mention what should be my service type. Cluster IP refers to the local service, that is an internal service. If I name it as a load balancer, I can just see it as a load balancer. Okay. So here in the values.yaml, I'm just going to make only one changes in the type. Let me name it as load balancer. Okay, so I want this service to be exposed as a external IP. I'm not modifying anything in the service.yaml because all these values it is going to pull from the values.yaml. Okay, and I'm just updating the values.yaml. In that, I'm just going to use the type as load balancer because it's going to use a default Nginx image. That is okay for me. So let me show you how do I apply this particular chart. Okay. Clear guys on where we are providing the values for the Helm chart?
Yes, Satish.
Okay. So let me just run this. So to install the chart, I'm going to say Helm install. Okay. I can provide a name for the chart. Name, let me call it as first app. And then I need to provide the location of the Helm chart. That is my first, sorry, first template. So I'm just providing the location because I have created the template under the first template directory. So I'm just going to use the Helm install command. Okay, there I'm just going to update this. So let me just install this. I think the latest version is having Helm install. What are the options they have? There is a version change here. So it's getting just a moment. Okay. So hyphen name is no longer needed. So Helm install. Start. Okay. You can see that hyphen name is not needed. So let me just delete this. So Helm install, name of the Helm, okay, and then provide that. So it might have created in the default namespace, okay, and status is deployed, and I'm having a revision, okay.
Satish, sorry to interrupt you. So, if we want to make a config change, I mean, if we want to point Helm to a different config, we have to use the same parameter, right? Hyphen config.
Yeah, the same thing. Hyphen config, you need to use the particular config file. So if I go to my dashboard, I can see one deployment. So there is a one deployment got created. So which is needed one pod because I have told it as one replica set should be one. Okay. And it might have created a service with the external load balancer. And I can just click on that. Let me give it some time. So this will update the Nginx default page. if I just need to get all the charts, I can just use Helm list all namespaces. So it is going to list the existing things when it was done and what is the status and all those stuffs. The app position is representing my, just wait. Yeah, this is my Nginx default page, /test. So it is representing my app version. Chart app version. Okay, in the chart, chart.yaml, I have the app version. So it is 1.16.0. Let's say instead of this 1.16.0, I want this to point to the version I have for let me just say Docker Hub. Nginx. Let me just take the tags. Let me use the 1.17.10 instead of 1.6.0. So this is how I'm going to show you how I'm going to make changes to the particular Helm chart. I have a predefined thing is running. Okay, in that I'm making a change to this app version. So let me make it as 1.17.0 and then let me hit save. I made changes to that. So let me upgrade this existing Helm chart using Helm upgrade. Okay, and name is called first app, and I need to provide the location where I have the updated YAMLs first template. So you can see that the second revision has been deployed. Okay, so if I go back to my replica set, I should see two replica sets now. Okay, and you can see that the image version has been updated. So if I refresh my page, I could see it is updating to the latest version of the thing. Okay, so without modifying the complete YAML and other stuffs, okay, with the predefined things, you can just use it. Okay, so this is the advantages of Helm. You don't need to write the complete deployment YAML or service.yaml. You just initialize the template. Inside that, if you want to make some changes, you can just do that. Okay, and you can just go for the other things also. Like you just modify this values.yaml and then chart.yaml, and the respective changes will be reflected on your Helm. Clear, guys?
Yes, it is.
Okay, so you just practice this. So basically you just create a template and deploy the Nginx, and then you make the changes to the version number in the chart.yaml. Okay, and then upgrade it. I gave the upgrade command here. No, I haven't given. Let me just give that. So test this and let me know. Once we come back, we will see how do I do a rollback in Helm, and then how do I basically delete a chart, existing chart, and then we will just I will just show you some of the predefined Helm charts available in public, okay, which you can use it. Okay, so we'll take a break and we'll come back at 11:40. Okay, so next concept we are going to talk about is called rolling back using Helm. Okay, so I have created a template and I have applied that, okay, and I have made some changes to the template, and I have upgraded the Helm also, okay. So let's say I want to roll back to a particular version. So the current Nginx version is, let's say, what's the current Nginx version we use? 1.17.10. I want to go back to the 1.16. So let's do that. The command is helm rollback. Helm rollback. What is my first tab? Next, the revision number. So let me go back to the revision number 1. So it is going to roll back to the previous version. So if I refresh this, I should be brought back to 1.16.0. So this is how you can roll back to a particular version in the helm.
Satish, can you tell like more about Helm and its advantages, or like why we should be using that?
So as per the base thing, one important advantage is like you don't need to write anything new, right? Like you don't need to write the complete architecture of the complete deployment YAML and other stuffs. Okay, and the next advantage is there are predefined Helm charts available on the public. You can just straight away start using that. Basically, you don't need to reinvent the complete wheel again. Okay, so if you want to implement Jenkins, okay, you don't need to write the same deployment YAML and all those stuffs. There are predefined things available, okay, and maintaining the versions, and then Helm can integrate with your Git repository very easily, okay. So the Helm charts can be pushed onto a particular repository whenever there is a change happened, okay. So you can maintain source control version codes using Helm. And adding to that, other than the advantage, it's easy to maintain and upgrade the code, okay. You just modifying the changes in 1 or 2 files, mostly in the values or in the charts. Very rarely you make changes to the template, okay. Whenever you want to add a new functionality or something like that, you will have the option of doing that. So that is where this is a lot better when compared to using the normal things.
Okay. Mhm.
Okay. So the next concept we are going to talk about in Helm is called how do I delete a infrastructure which I created using the Helm. So let's see that. So the command for that is Helm delete. You can use hyphen purge option also. Purge my application name, Helm application name. So purge is also they have removed in the latest version. Thank you. Made lots of changes in the latest version. So this application is uninstalled. So if I go back to here, if I go to my deployments, I could see the deployment is gone. It is still undergoing. So deployment is gone. Pods will be gone. By the meantime, replica sets will be gone. And the service is also gone. If we go ahead and refresh, the page will not be found. Okay. So this is the advantage of Helm delete. Done, guys? Everyone deleted?
Yes, Satish.
Okay. So the next concept we are going to talk about is called service mesh. Okay. So do you guys heard of this concept called service mesh or service auto discovery kind of things?
Yeah.
Okay. Can you please tell me your understanding about the service mesh?
So there would be like two important components of a service mesh. One being the data plane, where all inter-cluster communication, service-to-service communication,
Mhm.
retries, rate limiting timeouts and stuff we address, and that there are like a lot of data plane, tools which we can use, like things like Linkerd, Istio, and stuff like that. And then there comes control plane. So control plane is basically responsible for replacing your unhealthy evaluations, making sure the count under which you want to run. I mean, it's basically a traditional orchestrator, right? Well, what does it do? So yeah, I mean, a combination of these two would be called as a service mesh, where we ensure there is a secured communication happening, like inter cluster communication, and you can basically have visibility around all the calls we are making, both in and out of your cluster, both to internal and external services. Yeah.
Okay. So that's a good explanation, but that is more specific to a Istio or a Linkerd kind of things.
Yeah.
Okay. On general, a service mesh is something like that. Imagine you have your on-prem application. Okay. So you have your complete applications running in different API. So in the nowadays everything is a API world, right? So in that you can just say, okay, I have multiple versions of the API. Okay, and I need to control the communication between these multiple applications. How do I do that? Okay, so those kind of concept is called service mesh concept. I'm just talking about in the real-time on-prem, not on non-microservice world. Okay, and there is one more thing called service auto discovery. Okay, for example, in a API, when a application comes up, okay, with a new service, okay, then I need to automatically discover it, okay, and I need to maintain the configuration, and from there I need to route traffics to the newly available service, or if the service goes down, I need to update my configuration. So all those things, there is a API gateway which does the job for you. Okay, in microservices concept, okay, we are being talking about, okay, try to restrict the number of processes running in the container, right? So imagine an area where your container is doing a specific set of activity, like it should receive a request and process the request and then respond it with some return values. Okay, instead of that, on top of the container, I'm just going to write it like authenticating or like authorization on the same container. I'm kind of just increasing the load on the container. At the same time, if I want to do any network rules or something like that, okay, to control, okay, whether this request is coming from the valid host or something like that. So those kind of controls, if I give it on the container itself or on the pod itself, it is going to be overhead for the container. Okay, so that's why, what if I can take all this management part, okay, or the networking part of the container out of this container and give it as a separate component, okay, and then implement the service mesh concept, and at the same time I can implement the auto discovery, all those things in a common place. That is where Istio comes into picture. So Istio is also developed by Google, okay, and it is developed in Go language, okay, and this is being used on top of the Kubernetes layer, where it is going to take care of your authentication, authorization strategy, your service mesh concept, okay, and then even your network traffic control. So all these things will be taken care by the Istio. Okay, so prior to that, let me include a concept called sidecar. Have you guys heard of the sidecar concept?
Yes.
Okay, can you just tell me your understanding about sidecar?
Okay. So a sidecar, like basically ensures that, I mean, where a pod is running, in the same host, you are planning to create basically another container. It may be a log shipper. A quick example would be several Beats plugins, right? What we use to ship logs into Elasticsearch or Fluentd, stuff like that. Sidecars are basically a way of ensuring, let's say you have three different machines in a cluster, and you want a service to be running, like present there, along with your container. So yeah.
So this is something similar to what we have discussed in the yesterday. We have talked about a multi-container pod, right? So
Yeah.
on a pod, I'm running multiple containers. One container is doing the actual work. Okay. So the other container is taking care of the other auxiliary works I can talk about, because yesterday in the multi-container pod example, we have talked about one container will be writing a data, and the other container will be like hosting the data which is being created by the other container. Okay. So sidecar is the same concept. In a single pod, you run multiple containers where the sidecar is not doing the actual application work, it is doing the auxiliary work. Okay. In Istio, we will inject a sidecar. Okay. Whenever a container comes up, we will inject a Istio sidecar, which is going to take care of your service discovery or service mesh call. Okay. Or it needs to, if you want to offload the authentication and authorization mechanism, all these things can be done by the sidecar, and only the actual request goes into the container. The container will just receive the request, process it, and give back the response. Okay. So the network traffic routing, the service discovery, all those things will be taken care by this sidecar. So Istio works in the sidecar model. Okay. So this is what service mesh will look like. Okay. So you have a microservice and you have a sidecar. So sidecar is taking care of the communication. If you see this example, this sidecar will enable communication between these two containers. Okay. So it is not connected to this container directly. So this kind of concepts are being implemented in the service mesh concept using sidecar injection method. Okay. So the next concept is called, this is the Linkerd example. Linkerd is different from Istio. Okay. So this is basically, you have a service and you have a sidecar injected. So all the service mesh calls will go there. All the calls will go to the Linkerd, and from there, the application call only will go to the service. And we have a centralized service discovery option, which will collect the data. And then if the new service comes in with the Linkerd, it is getting updated, so that whenever there is a call needed, it is going to get updated automatically. Okay. So this is an example of a service mesh. Okay. So the next, clear on this service mesh, service discovery, and then centralizing the authentication and authorization and all those. Are you guys clear on this concept?
Can you repeat once?
So basically, my core aim is just to restrict the container or the pod. Let's just give it to a container. The application container should process only the application data. Okay. It should not process any other additional things like taking care of the network routing or taking care of the authentication and authorization. So nothing it should do. It should just receive an application request, process it, and return back the query. So this is the basic idea about this. And adding to that additional activities like network routing and then network authentication and authorization, you may also need the service mesh, and then you may also want to have the service discovery, where when a service comes in, it automatically updates in the centralized database. So whenever I want to call the service, I will get the details from the service discovery and then connect to the particular service. Okay. So these kind of things are done in Istio using a sidecar method, where an additional container will be implemented. Okay. So additional container will be implemented, which is going to take care of this, all these activities like doing the service mesh, controlling the traffic, okay, and then controlling the routing, taking care of authentication, and all those information it is going to do that way. So there's Linkerd is a sidecar which is injected with the service A. Whenever a request comes in, the request goes to the Linkerd, and from there only the application related thing is sent to the service A. Okay. and then the response will be sent back, and routing and all these things will be taken care by the linker D, and authentication and authorization can be also taken care by the linker D. And if there is a service comes up, if you want to update the service discovery database, it can also do that for you. Okay. And adding to that, it can also take care of the management part of it. So if a service goes down, I want to do, okay, and like how many percentage of traffic I need to transfer it. All those management part of things also can be able to do by the Istio. Clear? Is it clear?
Yes.
Okay. So let me talk about the Istio architecture. Okay. So Istio majorly has 4 components. Okay. So basically there will be a envoy proxy which will be injected with the service. So this is what we have talked about, the sidecar. Okay. So basically there is a service and there will be envoy proxy, and all the like service mesh related information will be communicated via the proxy. Okay. One proxy can communicate to another proxy. All the data will reach the proxy. From there only it will communicate to the other services. So this is one important component. It's called envoy proxy. Okay. It's a highly performance proxy. Okay. It can take care of multiple things. It can do the load balancing. Even you can do the SSL termination here. So you don't want, excuse me, you don't want the container to be taking care of the SSL encryption and decryption. So proxy can do that for you. Okay. It can do the health check. Okay. It can just do the percentage based traffic control. Okay. And if you want to collect metrics about the particular service, it can collect it. All those things will be done by the proxy. This is called envoy proxy. Okay. And next is called mixer. Okay. Mixer is a component which enforces the access control and usage policy across the mesh. Okay. So basically it can take care of your like it can communicate to your centralized access control system, and from there it can get the access related information and then pass it on. So for example, if the request is coming from this user, okay, this user I want to allow only this particular service, those kind of things. Mixer is the guy who can enforce the access control policy. Okay. And next is pilot. Okay. Pilot is a guy who takes care of the service discovery. Okay. So he takes care of the traffic management capabilities. Okay. Canary rollout and all those things will be implemented by the pilot. Pilot takes care of the network routing rules. Okay. And Citadel is the authentication service. So from the mixer, it can collect the details and send me the configuration details. Okay. And then next is called your galley. Galley is nothing but your similar to your etcd, where all the configuration validation will be done. Okay. So basically the configuration validation and other things, and talking to the underlying operating system like the Kubernetes, all these things are done by galley. Okay. And Citadel is for the end user authentication. Pilot is for controlling the network, and mixer is to communicate to the third party authentication system. Okay. Clear, guys? So the major components are envoy proxy, which takes care of all the proxy related stuff, load balancing, metrics collection, all those things. Okay, it does. And then you have the mixer, which basically communicates to the external authentication system, and pilot takes care of your network rules, and galley basically takes care of the validations, configuration validation, and Citadel takes care of the end user authentication. So these are all the core components of Istio. So guys, sorry about this. So basically we have this is the Istio configuration. Okay. So in the Istio, what we are going to do is we are going to host an application. Okay. So this is how we are going to see this example. So there is a predefined application. Okay. On our Kubernetes cluster, we are going to implement Istio on a particular namespace. Okay. And in that, we are going to deploy an application. Okay. which is basically going to host a product page. Okay. And in the backend, it will be calling multiple different services. Okay. So Python is the UI. Okay. The product page is developed on Python. So I will be connecting to this product page, and this will be pulling information from two services. One's called reviews and other called details. So the details will be coming up from a Ruby based application and the reviews will be coming from a Java based application, which will be getting the rating from the Node.js based application. So in the Java application, I'm going to have three different versions. In one version, it will not have any star rating. In another version, the star rating will be in black. In another version, the star rating will be in red color. Okay. So this is the application we are going to use with our Istio to see how I'm going to restrict the traffic or route the traffic based on the input coming from the user. For example, if a particular user logged in, for that user, I want him sent to be only to a particular, let's say, red star version of the application, I can do that. Or otherwise, I can see example of a canary based deployment. Imagine I want to send 25% of the request goes here and then 75% of the request goes here. That's what we have talked about, a canary deployment, right? So how I'm going to do that? So this is what we are going to see that. So first of all, on our Kubernetes cluster, we are going to install the Istio. On top of that, we are going to install this application, which is going to have 1, 2, 3, 4, 5, 6 Docker containers, which is having different versions of the application. So only in the Java based application will have different version. Others will have only one version. So this is the example. We are going to see it in the Istio. Clear, guys?
Yes, Satish.
Okay. So I'm going to do everything in my master. Okay. The reason being it is, okay, I may need to install Istio CTL and all those stuffs. On your mission, you may have some issues in doing that. Okay. And I have some commands which will be just running on the Linux based. So we will do that. So everyone, please connect to your um, Linux master. So basically connect to your jump host. From there, do a SSH to your master and do a kubectl get nodes command. So I'm in my master. So let me run the command kubectl get nodes. So I'm able to get all the nodes. So let me know once you guys are connected to the master and you are able to run the command kubectl get nodes. Okay. So everyone connected to the master, guys?
Yes, Satish.
Okay. So first, let me do the install. So the latest version is 1.6. So I'm just getting the URL for the download. So run this command on the master. Ensure that you are in the home directory of the Ubuntu user. So this might have created a folder called istio-1.1.1. So let me know once it is done. Done, guys, everyone?
Yes, Satish.
Yes, Satish.
Satish, just one thing. Like, do we have Linkerd specific scenarios? Because like Istio, like probably I guess like we will not be using Istio. So like it's definitely it's good for an example, but I just wanted to check if.
No, in our curriculum, Linkerd is not included actually.
Okay, no problem. Yeah.
Okay, so let me go inside this particular directory. So this is where all the informations are going to be there. Okay, my istio-ctl binary will be there. Okay, my sample applications will be there. My installation YAMLs, all those things will be inside this directory. So let me just start applying that. Okay, so next is, as my istio-ctl will be there in the bin directory, I need to update my path variable, okay, to use the current bin directory path also. So run this command. So this is going to update my path variable with the current directory path also. Okay. Run this command. And next is in the install directory. Okay. Install tree. Sorry, sudo. So if I give the tree command, okay, so inside this install directory, I will have the list of files in the install. So the installation is available for different versions of Kubernetes operations. So if I use console, if I use GCP, so I'm going to install it on Kubernetes. Okay, in that I'm going to have the Istio initializer files. Okay, there, sorry, Kubernetes Helm. In the Istio initializer, I have some files. So this will just do the initialization steps. Okay, this is the directory. I want to run all the files which are starting with the cred. Okay, in this directory. So I want to apply all these 4 files. Okay, so this will get my Kubernetes ready for the Istio installation. Okay, so I'm just going to apply all the 4 files. So I'm just going to write a small for loop. I'm just going to run this. So this is the command I'm going to run. So run this command on the same path. So this will apply all the prerequisite setups needed for the Kubernetes cluster. I'm just applying that using this command. Next is we will start implementing the STO. There are two ways you can implement the STO. One is you force the encryption between the communication, okay, or you can just skip the encryption. So for our lab purpose, I'm just going to apply it with the non-encryption method. So there is a file called uh, istio-demo.yaml. So let me just run that tree command again. So I'll show you. And install Kubernetes, you will have a file called istio-demo.yaml. You see that these two files. So the istio-demo.yaml will implement the istio without TLS. If I just use the -auth, it is going to deploy the istio with TLS. Okay. So for the demo, I'm just going to use it without TLS. So let me just run the command kubectl apply -f. This will implement the istio. So once the installation is done, it is going to implement multiple services like services. You see that it is implementing the Galley, egress gateway, ingress gateway, Grafana, Kiali, istio policy. It also going to include my Prometheus, and all those things is going to come in there. So let me show you what are all the services it is going to implement. So kubectl get svc -n istio -system. Okay. So these are all the services I should see after implemented. So Grafana, Istio Citadel, Egress Gateway, Galley, Ingress Gateway, okay, Pilot, Policy, Sidecar Injector, Telemetry Service, Agent, Controller, Query, Kiali, Prometheus, Tracing, and Zipkin. Okay. And so get service. So let me get all the pods and ensure that all the pods are in running or completed status. Clear kubectl get pods -n istio -system. Still container creating. We give it a time because I want all of them to be in the running state. I can also see it in the dashboard. So let me change that to the session got timed out. System. Okay. These are coming up. So telemetry is the only thing pending. Let's give it some time. Yeah. So all these pods are came into my running state. So let me just validate this in the command line. So guys, let me know once all your services are coming into all the pods came into the completed or running state. Then we can start deploying the application. Then we will start seeing example about routing and all those stuffs. Guys, done? Everything came into the running state?
Yes, Satish.
Okay. So next is I need to enable the istio injection for a particular namespace. Okay. You can either do it on a particular namespace or while implementing, okay, you can just do that also. While applying the particular application, you can also inject the istio. Okay. It is for the sidecar injection concept. Okay. So first of all, let me show you how do I enable the istio injection for a particular namespace. I'm just going to do it for my default namespace. So I just need to add a label for my namespace where it is going to have the istio injection is equal to enable. That means any application coming on the particular namespace, that sidecar injection will be enabled and istio will start maintaining the service mesh and all those concepts. So let's do that. kubectl label label namespace default stio hyphen njection equal to enable. So I'm just adding this label. So once I add this label, any applications coming on that particular namespace will have the your sidecar injection will be enabled. Okay, so let me just give that to you. Once it is done, let me deploy the application which I showed to you in the PPT. So the application YAML deployment YAML is in the samples directory. I will have the application deployment YAML. So kubectl apply -f samples book info platform q book info .yaml. So this is going to create the required deployments, okay, and exposing the service and all those things it's going to do. So in the PPT, I have shown you, let me show the PPT. So we are going to have one product page deployment, one details deployment, one rating deployment, and then 3 reviews. So I should see 6 deployments, one detail, rating, product page, and then these things. Okay. And from the service perspective, I should have 4 services. So as per this, product page service, review service, rating service, and detail service. So detail service, rating, review, and then product page service. Okay. So now let me just do the kubectl svc. So these are all the services, 4 services. Okay. And if I do the kubectl get pods, I can see details, product page, rating. So let all the pods come up. Give it some time. Product page is coming up. Let's give it some more time. Yes, all the pods came into the running state. Okay, so now I don't have any routing rule or anything available. If you see this, let me go back to the default thing. So I have this many pods running. So I will be having this many services running. Okay, so there is no ingress or anything. Okay, so let me do one thing. Let me create a gateway. Okay, and from the gateway, I want it to be redirected. Okay, so let me apply this. Next, let me create the default ingress gateway. Okay, and then try to access it from the particular thing. So kubectl apply -f samples book info networking book info -gateway.yaml. So there will be a gateway got created and there is a virtual service for the network book info got created. So if I run the command, so everyone please run this command. So this will create a gateway, and if I just access the ingress IP and then get that, I will be able to get that. So kubectl get gateway. I can see this is accessible. So if I go back to my ingress controller, I will not see anything here. So basically, if I change it back to my Istio system, there I can see a service called service with external endpoint. So Istio ingress gateway. Let me just open this URL and let me just say /PRODUCT product page. I can see the application loading. So the Istio has created an ingress gateway. For the ingress gateway, I have created a gateway called product page. If I access this with the product page, it is going to pass me to this particular application. Ingress Istio URL and add product page at the end. So this is the sample application which is written in Python. It is going to get these details from my Ruby application, right? The details are coming from this and this review. So the default application doesn't have any review field. Okay, these reviews are coming from the Java application, and the value for the reviews are coming from this Node.js application. Okay, so this is the high level about this application. So everyone got this page? Guys, let me know when you got this page. Then we can start writing some default rules and then proceed further.
Satish, where to get this URL from? Like, I missed that.
So basically go back to your dashboard and go change the namespace to Istio system. In that, go to services. You can see a Istio ingress gateway. We'll get the URL there. And once you get the URL, at the end, put the /product page. So product page is my application name. Done, guys?
Yes, Satish. Yeah.
So everyone got this page?
Yes.
So in this, let me apply a default destination rules. Let me just show you the default destination rule. .pem. So let me show you the default destination rule samples, book info, booking, destination rule -all dot YAML. So if you see that this is the default destination rule, when the host is product page, it should be pointing to V1. Okay. And for if the host is reviews, okay, it should point me to V1, V2, and V3. Okay. This will be in a round robin fashion. Okay. And next is when the detail is details, it is going to point me to this V1 and V2. Okay. So let me apply this rule. So basically this is going to, when I access the product page, it should access the product page. Okay. And internally, it will be calling the rating service, sorry, review service. Review will be V1, V2, and V3, and rating also V1, V2, and V3. Okay. And then it is V1 and V2 for my details page. So let me apply this default destination rule. So the same command, let me apply this. So prior to that, I will just show you, if I just refresh this page, nothing happens. No change happens here. So it will always pointing to my that reviewer one. Okay. I think the rule is already applied. Okay. If you refresh this page, you can see it is kind of changing between reviewer one, the one with the red star, and other with the black star. So this is something, I think it's already applied. kubectl apply -f, the default destination rule. I think this destination rule is already applied. Okay. Okay. So this is how I can just say, when I call it the product page, it will be pointing me to the one version. There is only one version of product page, that is V1. When I call it with the reviews with the label V1, it should point me to the label V1, version V1. Label is V2 means it should point me to the version V2. V3 means it should point me to the version V3. Okay. So now let me just create a different rule. Okay. I'll just walk you through the rule. Cat samples book info networking virtual service reviews test v2.yaml. Okay, so basically what I'm going to do is, in the header I'm just looking for a user called JSON. Okay, if this is basically URL based redirection. So this application is designed in such a way that if I log in as a user called JSON, okay, this JSON will be put in the header. Okay, so if I'm logged in as the JSON user, I should be toggled between V1 and V2. Okay, so let's do that. So in my application, let me sign in as the username is, what is the name they have given? JSON, JASON. And the password is also JSON. So I'm logged in as a JSON. If I refresh now, it is switching between multiple versions, right? I'm getting the green star and black, red star, black star, and then no stars. Now let me apply this rule. CTL apply -f. So there is a new service got created. If I refresh this page, I can see I am restricted only to the black star. If I sign out and then refresh this page, I am restricted only to the V1. So this is the rule I have written. So basically, if there is no one signed in, if not a signed in user, I can just say only version 1 should be displayed. If I signed in as JSON, I should be shown only the version 2, that is the black star. So I have updated previously. The rule was, it was just giving all the versions in a round robin fashion. Now I applied this rule. So if a user JSON logged in, he should be shown only version 2, and for the other user, it should show only version 1. So this is how you can use this. So just try this. So once you do that, log in as the user called JSON with the same JSON as password, then you will get only version 2. If you log out, you will get only version 1. So in this PPT, version 1 refers to no star, version 2 refers to black star. That's what I'm seeing here. I'm logged in as JSON, I see only black star. If I log out, I will see only, I will not see any stars, no star. Clear guys on this concept? User-based routing. Guys, done?
Yes, Satish.
Okay. So next, let's quickly see information about fault injection. Let's see. So, okay. equals info working service waiting test delay.yaml. So basically, this is a concept of injecting a fault, or you can just set up a delay in while accessing one service to the another service. You can use this rule. So till now we have talked about only for the particular user. I want the V1 to be displayed. Okay, sorry, V2 to be displayed, and other user it should be V1. Okay, here I'm intentionally injecting a delay called 7 seconds. Okay, so let me just apply this and I will show you that. kubectl apply -f. Okay, so this route is created. So let me ensure this I'm logged in as JSON user. JSON. I'm logged in as JSON user, and let me go into the console. If you press F12, it will open a console in this thing. Let me refresh this page. So in this page, you can just see the timeout is 6 milliseconds. And I'm getting a error saying that the product review is currently unavailable. Okay. The reason being this concept is, so basically there is a default timeout set for this particular page. Like basically when the review is trying to connect. So basically when the review is trying to connect to the rating, there is a default timeout set of 10 seconds. Okay. But in the network rule, what I'm doing is I'm reducing that to 7 milliseconds. That's what in the networking rule I have done. So it is not able to fetch the details. Okay. So that is the reason if I'm logged in as the user JSON, I'm getting this error. Okay. If I sign out, I'll be able to get the review, because only for the JSON user, I have injected this fault tolerance mechanism. So a fault injection, intentionally I have induced a fault that I know that the timeout between the rating review and the rating system is 10 seconds. I'm trying to force it to 7 seconds. So because of that, when I logged in as the JSON user, I am getting this error. But if I log out, I'll be able to see the actual value. So if you want to troubleshoot these kind of activities, you can use this option. So you can inject a fault. Okay. So like that, you can do n number of activities. Okay. So let me just delete this rule. kubectl delete -f. Okay. Now, if I go back and do that same page, if I refresh this, I should get a value now because I have deleted the rule. Or otherwise, if I increase the timeout from 7 seconds to 12 seconds or something like that, I will not get this error. Okay. So this will be a typical scenario where multiple teams developing these microservices, you want to test them by manually injecting the fault. You can do this way. Okay. So we have seen an example of how to, based on the user, how do I route the traffic, and intentionally including a fault also we have seen that. Okay, you guys try this and let me know. Clear guys on the fault injection? Done guys? Yes, did you completed that?
Yes, Satish.
Okay. Now let me show you example of circuit breaker. Okay. Circuit breaker is also another concept where you can decide how many requests a particular container can process. Okay. At the same time, okay, if it is going beyond some particular condition, you want the connection to be terminated. Okay. So those kind of scenarios you can just do it. So for this, I'm going to bring up a container called http bin.yaml. So let me run this command kubectl apply -f samples http bin.yaml. So this is going to create a service called http bin, and it is going to create a deployment called http bin. Okay. So next, what I'm going to do is I'm going to create a destination rule where it can allow only one concurrent connection on the mission. So this is my YAML is going to look like. So let me run this. So what it is going to do is it is going to create a destination rule for the HTTP bin. So it can allow max connection is 1. Okay. When I do one concurrent connection, it should allow it. Okay. And these are all the ejection timeout and ejection percentage. It's 100%. Okay. I have two UOFs. Nothing wrong here. Something wrong with this paste. This is fine. Okay, so there is a destination rule got created. So next, let me add a client, okay, which will be communicating to that. So kubectl apply -f samples http bin sample client and then fortio deploy.yaml. Okay, so it will create a another pod. Okay, from the pod, let me just try to run some multiple concurrent connections. So this is going to create the pod, and then I'm getting the pod name to a variable. So this will get the pod name to the variable, and in this, let me execute a connection, okay, to the HTTP bin pod which I created. So this is going to give me the correct output. I have got the output for this HTTP 200 OK. So this is going to give me the correct output because I have made only one concurrent connection. If I increase that connection to 2, let's see what happens. So basically, I'm increasing the concurrency to 2. I can see I'm getting an error. So I can see 95% of the request is successful, 1% is failure. That means when it is trying to run concurrently, 19 requests got successful with one concurrent thing. Okay. And then I got a error with one with the failure. So basically it is just discarding any concurrent connections more than one. Okay. So this command I will do. In the same command, let me try to run the concurrency with 3. Let's see what happens. You can see that the number of failures is getting increased. Now it has become 60% successful and 40% failure. So basically 60% of the requests are going as an individual request, 40% is trying to make a concurrent connection, which is causing a failure for me. Okay, if I just run this exe, so basically there is a proxy running, right? Istio proxy running. In that, if I try to run that, there were 32 requests pending. That means 32 requests has been not processed by the container or processed by the proxy. So when I run this, so out of this, 9 requests has been rejected because of the rule. That is the circuit breaking. So this is how you can inject a circuit breaker inside the proxy, and you can control the traffic, or based on that you can inject a circuit breaker. So finally I can delete this rule. Now that I have created the rule with the name HTTP bin, let me just delete the rule. Okay. Can delete the particular rule. So in this Istio, we have seen about user-based traffic routing. We have talked about fault injection, okay, and also we have talked about circuit breaking. Okay, so let me know once you guys practiced it. Then we will go with the canary deployment. So where we will start writing rules to route the traffic via percentage. Let's say I want to forward 25% of requests to particular service and 50% to other service, and then we will keep on increasing that. At the end, we will just close it with the 100% on the canary. So this will be an example for my canary deployment. Done, guys? Shall we proceed to the next topic? So let me just see an example about our canary. Okay, so let me show you the example. Samples, book info, networking, virtual service, reviews, 50. Okay. So if you see this rule, so basically it's going to talk about 50% of the request is going to go to the V1 and 50% of the request has to go to the V3. Okay, so let's just apply this rule. CTL apply -f. Okay, now if I go back to my application and ensure that you are logged out, because if I logged in as a JSON user, it will be still pointing me to the version 2. Sign out. So if you see that I'm being transferred between only with the no star and the red star. So if I want to forward everything to the red star, okay, let's see how do I do that. So I want to forward everything to my red star. So there is a YAML for that. Cat samples book info networking virtual service review v3. So this YAML is going to push everything to the v3. The 100% will be pushed to v3. Let me apply this. Q CTL apply -f v3. So if I come back and refresh this page, you can see every time when I refresh, it is taken to the v3, which is basically my red star. So this is how you can do the canary based deployment. So in the first example, I have seen 50% is going to one, and the next example, 100% is going to the particular version. Okay. Done, guys. I think with this we can conclude this training. So we have seen an example about STO, where we have seen about user-based routing, and then canary deployment also we have seen an example, and also we have seen the fault injection, and then circuit breaking also we have seen an example. Has any other questions or topics which you want to discuss?
Yeah, it was a very good training.
Okay.
So to practice it.
Okay.
If you have any other documents or links, if you want to share with us, you can do
Yeah,
that.
I will share you the lab guide. Like as you got it for the Ansible, you will also get that.
Yeah. Yeah. Thank you very much.
Yeah.
Thank you, Satish.
Thank you all for your time.
Thank you, Satish.
Yeah. Thank you.